Share screen. All right. So today we are going to do exactly that. We're gonna generate our data file to be able to start making those nice PRH files. We can tell what the whale's doing. We have a lot of specifics kind of laid out today about what exactly we're going to be looking for. But in the end, we don't really have to worry too much about all these specifics, because really what we're doing is we're going to start with reviewing where we're at, and then we're going to be running the main CATS PRH tool, and that's what we're going to be working on for the rest of the day. We're going to kind of use our data that we've created so far, or data files that we've created so far from the raw data, and we're going to output this PRH file, which is kind of the workhorse file that we use in Biologging a lot because that represents what our whale's doing, what our animal is doing, and we can use that file to then do all the analysis that you want, and do all the science and all that sweet stuff that Ari and Jeremy and others have shown us so far, and that we'll talk about tomorrow with a bunch of really cool guest speakers tomorrow. So tomorrow we'll get into both stitching the video and the audio together, and then we'll also get into some of the actually using that data file, that PRH detection script. So we have a number of great guest speakers tomorrow. Will and Sherelle are going to go over some event detection. Stacy's going to come in and talk about some tag tools. Emily, Sarah, and Nicole actually will be talking about video audits, and Boris, and working with TrackBot. Jen's going to talk about that with us, and we'll just kind of talk about using some data tomorrow. But today, generating the PRH file, ending with this output of the PRH file. And just note where everyone's in a little bit different place with this coding. The afternoon sessions have been really good chance for people to kind of come in and ask questions and say what and figure out what their problems are. People have been sending me a lot of errors, which is good. I appreciate that. I'm gonna one of the things I want you to think about, we'll show over some of the errors and as we talk about where we're at right now, and kind of and debrief a little bit. But one of the things I'll just remind everyone is that coding, it's okay to be frustrated. It's okay to not know exactly where we are at any given time. I think about coding as like a puzzle, like a game, like where it's just like we're just trying to figure it all out. It's just like and it's okay if we're not always finding the answer. In fact, it's a lot like those board games you play, those collaborative board games you play that actually you lose most of the time. This is one of the games I love. It's hard to find right now for obvious reasons, but it's a great game that kind of gets you to feel like, oh yeah, we lost this one again. It's always a puzzle because you keep coming back to it, trying to figure it out. And when you finally get to that answer, that animal behavior, you're stoked. And so like this is the part of the data analysis process where I kind of feel it's like field work, where we're actually like coming up with data. We're actually justifying everything we've done, even though it's like a frustrating part. When you finally get those solutions, it can feel really good. And so I love games and puzzles for that reason. So that's kind of where we're going for today. So let's stop this share.
Can I just jump in there for a moment too, Dave? Like I said at the very beginning of this, I'm sort of a beginner to intermediate user with a lot of this stuff. And I am a fourth-year PhD student, so I've been working at this for like 3 years. So the first probably 20 times that I went through how to make this PRH, I would come up with questions and go to Dave and go, okay, Dave, why is this doing this? I'm not really sure. Why does this step come before here? Where is this data supposed to be coming from? So it's by no means an easy process to get all of this together in a few days. So really don't feel bad if pieces are going over your head and you're still on step 1 and we're on step 4, and the goal is that we have these recordings. So if you have some time later to go back and you can check certain pieces and see, okay, what did we do on this step? So that's why if we kind of go through things a little bit faster, we're hoping that those recordings can be there as like as a tool later on. Because it's not straightforward as Dave's been saying here.
Well, we're working to make it more straightforward all the time. So we're going to keep going, and with your feedback, it's been awesome to kind of keep making these. Where are the parts that people get stuck and figuring it all out? One of the things that is, though, if you haven't discovered it yet, I'll just go and put us back to the GitHub page. Of course, can download the code, but also has this wiki that Will's been working hard to put together. That basically has all of these steps kind of laid out here. So if you ever are trying to do this on your own or try to do this afterwards, come on back to this wiki page, and that can help you work through it. And today we're essentially working through this whole section here, the PRH file creation section, section 6. So we're basically working through this whole section today. to end up with that PRH process. And this is kind of the basic workhorse script. Now that we have our data imported, like how are we gonna work with this? How we have this piece. Okay, so I want to start with a little bit of overview of where we're at and where we need to be right now. In our example data folder, you should have been able to create both a movie times file, which is from the that CATS PRH step 1 that we'll go over, as well as an audio data folder that has all of our WAV files. Now we won't really need either of those files till later in the day. We won't even really need the movie times file very much. But they are here available on the example data website in the Google Drive. So you can grab those if you weren't able to create those files. You also have created a mat file, a .mat file, which is essentially all of these CSV files created, synthesized into one mat file that has all of our data in there. Now, a couple of notes about those. Well, first, let's talk about the mat file, because most of you guys did that last night, and then we'll go back to the movie times. The mat file, a lot of you guys ran that last night, which is awesome. And a lot of you guys got to this point. A couple of things I'll point out. One is at the end of it, you will have created a couple of figures. One of them is this, it'll create basically the depth profile here of that tagged animal. And some of this, it spits it out as a check. It's just as a way for you to kind of see what your data is. This one's actually, when it spits it out for you, it's actually asking for some inputs. It's actually asking for, oops, I deleted all the data, but it's a live script that's asking for your, for a data, and it's asking you to click on the locations of the tag on and tag off time, and you can zoom in, and we'll go over how to use that a little bit later on today. But it's a chance to kind of spit out some information about your deployment. This is the first time usually you've seen your data and you want to know something about it, and it's a chance to kind of look at it and say like, okay, yeah, I have data, it's looking good, I'm going to charge that tag, redeploy it, etc. So it's kind of some of those things built in so you can kind of see your data. It's not, necessarily perfect for a tutorial, or you will see it all in good time, but when you're in the field and you want to, you see this data right away, this is one of the tools that kind of pops up automatically. Now, if you got to this point and you didn't know what to do and you close the window or you errored out of it, it's still okay. Like at this point, the mat file will have already been created. So as long as you've got this mat file created, you're going to be good. Now, the other issue that people were asking about that kind of happened is that they're like, okay, they're going through this data and that stopped. It stopped at CSV 17. Oh, okay, well, that's good. Now, all of this data from CSV 17 all the way down to CSV 58, that's all data that was after the tag popped off the whale. It's all like floating data. So usually after we import CATS data, believe it or not, we actually just delete all of that data and just get rid of it all, because everything from CSV 17 to the end is all just tag floating in the water. It's not actually useful for us. We have plenty of files just taking up space, and so anything we can do to minimize that, we can. Now, you can decide for yourself if you want to do it that way, but that's our procedure to do those. Well, I see a lot of questions coming in. Is everything good? Do we need a pause?
Everything's good. There was a question on whether the afternoon sessions would be recorded. We haven't been, just because it's pretty much 3 hours of and do a little bit of troubleshooting, and yeah, so we have not been recording those. But is that any big information or any big errors that come up in that session, we'll sort of talk about at the beginning of the next day. So
we actually do have a recording from last night. I didn't post it because it's basically just like back and forth and ranting and raving and back, but like kind of troubleshooting and back and forth. But we could post it if anyone wants to watch it. So we do have it. But it's good. Okay, so there's so far so good. So those are some of the questions that came up with the import CATS. But mostly, as long as you got this mat file created, you should be good. That, of course, that mat file is, I'll load it from my hard drive version. That mat file includes our basic workhorse functions here, our data, a time, which are our scripts that we're using, are basically all of the CSV files imported into that data. So it takes a second to load these things, especially, I guess, while it's processing Zoom. But that's our main piece. We'll let that load for a second, and then I'll show you some of the other errors. The other things that popped up from that script are just a general check of your data. So an accelerometer, magnetometer, pressure sensor, spike. And so you just have a chance to kind of look at your data and say, like, is it kind of what we expected? You know, like you can see here, you can kind of just start to get used to what your data looks like. Here's all kind of data. This is the tag on the boat. The tag's on the boat. It's just kind of sitting there with the z-axis at -1. Then all of a sudden it's up on a pole, so it's upside down. The z-axis is upside down. The tag's not upside down. And then all of a sudden right here, the tag goes on. You can see that big spike, and as the depth sensor starts to go down, and then you have data. You have all three axes kind of given data for a long time. And then at the end, the tag pops off, and then it's floating at the surface here. So this is just a chance for you to start looking at your data when it pops off right away. Okay. So here's our data. It's in that data structure. That's everything that pops off there. The other piece I can introduce you to is this Hertz's structure, which has the sampled data, which from your accelerometer, all the different values from your sampled data accelerometer. And that comes from this the text file. If you guys are CATS users, it comes from this text file that has the recorded information of how your data was sampled. So this accelerometer data was sampled at 400 Hertz, the gyroscope was sampled at 50 Hertz, et cetera. And so that then is stored in that structure for your information about the file. Okay. The other question I wanted to go over was the main CATS, was the make movie time script. People were running that on the first night and then still trying to run it last night. There's a couple of critical errors that came up with that one. And some of them are fixable and some of them are not fixable. One of the ones that unfortunately is not fixable is this MEX error. So a lot of Mac users were getting this MEX file error. And I unfortunately at this point do not have a good solution for that. I'm not a coder really, and Will and I, neither of us are really like coders or programmers. We're biologists, and so we tend to like do okay, well let's work. If it works, we'll just keep using it. And so some files like this, we ended up using this this mmRead function to basically read in all the video files. Well, it works pretty well, and so we've always kept using that. There might be other options and better options out there that we can explore in the future, but it seems to be giving problems and throwing errors with Macs. So if you're using a Mac, you're probably going to have to grab that movie times file from the hard drive, so you can use so you can actually move along with us today. So that was an error that's cropping up. The other error that cropped up with Macs, good news. There is good news for Macs too. One of the errors I expected to crop up was a lot of file structure directory errors, and that didn't seem to happen. So a lot of people were able to like find files effectively with Macs. Sometimes you have that slash or backslash error with Mac PC issues, but that seemed to be okay. So that's good. And then there are other errors that popped up with Macs is that while in Windows, you have this okay, well, it tells you what to do. Select the first movie file here. In Macs, you're not getting that piece of information there. And I don't know why in Macs, it doesn't give you that insight into what to do. There might be some coding thing that I can try to switch to do that. We'll also try to update the GitHub wiki so that it says really precisely like what you're supposed to click on when in case you're trying to use a Mac for those things, because that error will crop up over and over again where we expect you to have that information there and it doesn't have it. Now, one more thing that was happening with these files is that what you should have had as the output for the make movie times is this is a figure that pops up that shows you basically all of the frame times and the movie number for each one, and then what time that movie started, and just have this continuous record of all these movies were kind of sequential. Then you had a gap between movies 5 and 7 and a gap between movies 7 and 9. And you just have nice like increasing timestamps in here. That's not the figure that everyone got. Some people got a figure that looks like this. And I haven't yet figured out why people got one or the other, but the error is cropping up. It's basically just a way that MATLAB is reading the files in between them. You can see if you actually zoom in on these errors here. Oops. Give me some zoom. It's a zoom world. If you zoom in on these errors, you can see that every one of them is basically the same. There's a gap, a negative time jump, and they're all evenly spaced. And they're all evenly spaced at 15-second durations. And that's happening, something about how it's reading every file over and over and over again. So we've identified this error. I don't know why it's cropping up for some people and not for other people. If you got this error, I would love, and your final video looked like this. I would love to know from you like what version of MATLAB you're running, and et cetera. And if you want to send me the actual movie times file you created, that would be helpful as well. So I can try to troubleshoot that later on and get back to that. So if you got a final video that looks like this, you might also want to use the make movie times file from that we just put up in the example folder to use that for today. Yours will probably be fine. It'll work throughout the day. You won't really crop up errors, but when we make the final videos, it might give you some funny looking videos with some weird time gaps at some point. So we'll double check that at some point why that's happening for people. Okay, that's where we're at right now. So that's what our folder structure should look like. I put in a couple more folders, in a couple more things. You'll notice that there's a couple more things in this file now that we weren't in there before. There's this GPS hits file. Some of my lab mates make fun of me because you can pronounce that differently depending on where you do the enunciation. But there's this GPS hits file, which we'll talk about later, and there's the pics and videos file, which we'll use also as later to make the quick look. And so that just has, you can put as many pics and videos in here as you want from your deployments. But there's a couple in here that we'll highlight later, just if you put in an ID photo, which could be a fluke photo if you have one. We didn't have one for this whale. And a picture of the tag on the whale to give us some information and insights. So we'll talk about that structure later on in the day, but that's where that comes from. And with that, we're going to start basically, we're going to start going through the PRH process in that MATLAB file. And what we'll do today, we're basically going to be in the main room all day, but I will open up a breakout rooms right now just to have them open. So that if you decide, oh, okay, I'm a little bit, I want to grab a friend and go talk about this for a second else, you can go to a breakout room. Or Will and I are going to kind of switch off presenting the information today. If you decide, oh, okay, well, I have a question for, Dave's presenting, let me ask a question for Will, and Will can just pop in with a breakout room for you too. But also, first of all, I would encourage you just to interrupt us, because if you have a question, probably other people have that same question as well. So feel free to jump in there and interrupt us. But I want to open these up so you have that option if they're there. So I'm just going to open them. I think you might have to click decline right now. But so it's there, they're open. So that option is there, but so you don't have to go to a room, but that option should be down in your bottom corner that if you decide you want to, they are there to open. You can just go to a room of your favorite number. Okay. So far, so good. Give everyone a second to make sure you have all your ducks in a row here. You have your mat file, you have your movie times file. Oh, there's also this POS file, which we'll go over again as well today. You won't need that yet. You will need that towards the end of the day. We'll take like a break about halfway through when we're kind of working through this. So that's our main structures today: mat file, movie times file, and then the first thing you're going to use is this header file. So if you haven't checked out this header file, basically this is a file that it's a structure that we use. We're going to import it today. This is another thing, you don't have to do it this way, but this is how we read in information about metadata, essentially about our file that we use to help create our file. So part of it is, the critical ones here are the deployment ID. So we use a species name followed by year, month, day, and tag number. And that helps how we differentiate all of our different deployments. So you can use that throughout this process. We have this information here about the deployment location and the longitude. Now that's useful mostly because that's what we're going to use to generate the magnetic field of that location. So to actually find that magnetic field. So that number actually doesn't have to be precise. It can be because it's the magnetic field of the location. And so as long as you're within 10 or 20 or 50 miles, you're going to be pretty accurate for that location, and your whale moves around anyways. So those are, your animal moves around anyway. So those are all, that's fine. So it doesn't have to be precise. So you can use the same one for all of your different deployments from that location, for instance. But you could just use the tag on location every time if you want. Put in your tag number here, and then you have this switch right here. Ideally that's 0, but it's in there as like an error because you never know. Sometimes there's situations certainly where people have, where we have not put in the right time. We either used a computer that was set to the wrong time zone, or we forgot to sync our computer with the GPS. And so our tags, we know, are like 17 seconds off of what they're supposed to be or whatever. So it's just a switch in here that you could use to adjust your timestamps later on to keep track of that. So these are some, when it comes down to using your data, if there's an area, problem you're having with your data, we've probably encountered it at some point. And so these are some of the switches we have built in to help you do that. And so we can always talk about it later if you have that error. Now this whole section down here, we're leaving it blank for this deployment. But what it is it's a structure where you can either add in two different things. One is if you have a camera deployment that does not have really clear time start times of the deployment. If there's, for some reason, you're using an independent system, you're early CATS cameras are like this, but other tags are like this too. where in your data deployment, you have, so our CATS cams now have this really nice, really precise to the millisecond start time of their file, right? So day, year, month, day, hours, minutes, second, milliseconds with the file number. So they have this really, so we use that to say like, okay, that's exactly when the file started and that's synced up with the data. So it's not even an independent clock. It's the same, using the same clock to rate the same timestamp. So we use that information as part of our process. But if you don't have that and you need to sync up your video separately, you can use this to put in timestamps of surfacings. Then you can use because the surfacings are really easy to see in the pressure sensor. You can use these timestamps to put in a timestamp of a surfacing. So we'll hopefully get a chance to go over some of that example later on. But for our purposes today, we don't have to do that. The other reason it can use that for is this recording observed tag slips. So the other thing you can do is, like, one of the powers of video is just like I showed you with that gray whale. If you know where a tag slip is happening because you see it on the video, that can take a lot of the guesswork out of like trying to interpret the accelerometer data. So if you see that precisely, you can put in, okay, video number one has a tag slip from 342 in the video to 344.6. You just throw that in there and we incorporate that into as part of the process. So that's just an advantage to having videos, is that you can know some information about it as you're watching your videos to know that. And if you don't have that information, we'll determine it from the accelerometers, but this is just a chance to make that more precise and even more accurate. So that's just an option to do. So we won't do it for this deployment, but that is an option in there. So we'll use that header file originally. So those two pieces of information, that header file and this mat file, are what we're going to use basically over and over and over again throughout this process. Boom. Okay, so here we are, main CATS PRH tool. This is the one we're running today. This is our main script. Oh, sorry, one more thing I wanted to highlight is this idea of how to run scripts, because I saw some different ideas here. Here, let me open up this one. In our script file, our script folder, there's 4 different scripts, or 5 now, in our main CATS PRH folders. Don't worry about these ASVs; those are the autosave ones as I make edits. But there's these main ones. We've looked at the calibrate CATS. That's one we open up and look at. We've looked at this main CATS PRH tool. It's one we open up and look at. When we run the import CATS data, you can open that up and look and check it out, but you don't have to. So you can open that up in your MATLAB file and you can run it from within here. But the import CATS data is a little bit different in that it's actually a function, and all of the different other tools and sub functions and everything else in this folder, all these sub functions, all these utilities, all of these workhorse functions, these are all function format. And of these main ones, only this import CATS data is a function. And you can tell it's a function because it says function at the top. And that basically means you can run it from the command window by just typing import CATS data and then either using any of these input variables, expecting these output variables to come out. So you don't have to run it from within this script like these other ones you do. So that's just that basic MATLAB information there. And that's why you can just type in here like data equals import CATS data. Another piece that people actually found useful. Go ahead, Will.
Just a quick note on that too, with all the sub functions and things like that. That's why a lot of people have been getting the error that an undefined function or variable is being looked for. That's because it means that function is not, or that sub function is not on your path. So in order to make sure that doesn't happen, just put the entire toolkit onto the MATLAB path. Just click on that, add folder and subfolders, and then you'll have all of it in there. And so you can call any of these functions. The main PRH script is going to be calling some of those sub functions. So if something's not on the path, then it'll essentially look for it and it won't find it and it'll give you that error. So just to reiterate that.
Yeah. Make sure and we've gone over a couple of times, but if you still have questions, I can show you how to do that in your startup folder and stuff. And it was also listed in that worksheet from yesterday to how to add that to your startup folder so that you can not have that count find functions error, which would be common otherwise. But you can also do it from right here by just like Will was saying, is add to path, add these selected folders and subfolders to path. Okay, so we ran this yesterday. We had these switches. Some people, so we ran this. We had to make movie times. We're good. For the rest of the time, if you ever get interrupted for this process or anything, you're always going to start here for section 2, and section 2 is going to start importing our data. And then whenever you go start with section 2, we can keep moving forward sequentially, or like Will and I are going to pass this back and forth. We can start at section 2 and then go to the next, whatever section you're working on. So you can kind of start in the middle, or you're like, oh, I want to fix the speed, or I want to fix the tag slips. You can just go back to that one section using the information you already have kind of stored in your file. And then run from there on out. So that's kind of a new feature that we've been working to implement here, so that it can make it easier to like start over or lose track of your spot and go back to where you were. So this is what we're going to run. To run these cells, you can click run section, not the whole run, because that'll run the whole script, but run section, or the shortcut is on your keyboard is Control Enter. So you run that cell. It's going to end up clearing your max, and then you're going to navigate to it's going to clear your workspace, and then you're going to navigate to your folder with your data. So we're doing 31258. So here's my data file. So I'm going to select that data file, that imported cats file. And then I'm going to select that header file that we just were looking at. So those two files are the ones I'm going to select. Select the data file with surfaces and header info. I guess with a Mac, it's probably not showing you that, but select that order, select the mat file, and then that Excel file. And basically it's okay, here we are. So section 2 is now finished, and it's made an info file. And the info file is what this is now in my, this one. The info file is just created here. It looks at the same format as everything else, but it's this info file. Right now, it's fairly small because it just has one piece of information in it, a small 1 kilobyte file. All it has in there is that it has this cell number in there. So all this script is doing right now is it's loading my header file, reading that header file so I can get some information, and then telling you, okay, I'm at cell number 2, and I've run that file, and I'm going to save my new info file with that cell number inside of there. And then basically I'm cleared. All the information I need right now is what my file is that I'm working with and where my folder is, and then the headers file that has all that information from the Excel file. Okay, so then we're going to start working with our data. So the first step is, you can tell I like to get rid of useless data. So the first step is going to be to truncate our data files to kind of what we want to actually work with. And so even though we didn't import all those data, there's still like a little bit more data here than we like to work with. I like to try to minimize data, only work with a structure that we need to, so that there's not too much. Okay, so I'm going to run this section. Either click on run section here or Control Enter. What's going to spit out here is your data file, similar to what we looked at with the tag tools. And it gives you a chance to kind of like truncate your data. Now, there's a lot of different reasons why you might want to truncate your data or keep your data. Some people like the DTAG format. DTAGs start as soon as you throw it into the water. And so they always start kind of at tag on. And so that might be a part of your workflow. So you want to truncate it all the way and just have data that's on the animal. The same with the end. You might not want any of that data at the end. I like to keep a little bit of data at the beginning and the end, partially because we like to look at the videos before and after the whale comes off. Sometimes the videos are useful as you're approaching the whale or after the tag comes off. And so having data associated with that just kind of makes some of that workflow easier. So I tend to keep this a little bit easier. This yellow box is kind of selecting where it wants to go. There's going to be a lot of different ways to interact with these graphs over time. So all the instructions are going to be in different places, but they're because we've written these scripts at different times, but the information's there. So in this situation, we can use our zoom tool to zoom into one side or the other, depending on where you want to see information. And you can zoom in and zoom out. And for this one, I'm not going to worry about it too much. I'm just going to press enter because I'm ready to start synchronizing this. And then, nice. Uh-oh. Already having errors. Try it again. Okay, so it brings up my my data files here. I can either press 1 to set the beginning boundary or press 2 to set the end boundary. I don't need to, I can press 1 and just like, oh, I want a little bit more data over here. So I'm going to press 1 and like make my truncate file a little bit longer, or I can make my truncate file a little bit shorter. But this is good. So I'm going to press enter, and then I'm going to just press enter to accept those boundaries. And then that's going to be the length of my truncated file. I'm going to get rid of the data on the other sides. For the rest of the time, we're only going to be working with the data, this yellow pile here. It's going to take a second to run because basically what it's doing is it's creating a new file. It's a little bit longer. It's giving me a little function there. But it's creating this new truncate file in your folder that's just a little bit smaller than the one we've been working with. So like when we pass this over to Will, this is actually a critical file now that Will's going to be working with when we pass it over to him eventually. It's the truncate file and this info file. Okay, so far so good. I don't see a lot of questions popping up, but you know, as long as we're able to run that with us, so far so good. Okay, so all we're still doing is kind of setting up our data. We're gonna do one more step to set up our data. This step we're gonna start. Oh, sorry, one more thing that might have happened here is it might have asked you to load your cal file in that step. Might have asked you to like find that calibration file. So in mine, it automatically found it because I have my folder structure set up so that it's in a CATS calibration file, just like we have it set up in the example data workflow. But if you haven't set up your folder structure like that, you might have to navigate to wherever you downloaded this calibration file in this CATS cal 58, which will have your calibration structure in it, all of that data that we did a calibration for. We did it with a different tag yesterday, but it's the same idea that you have this CATS cal 58 data file. And that just creates this cal file, which has all of our bench calibrations in there. So this is that point where you're inputting that calibration file in there. We haven't used that calibration data yet, but it's just thrown in there. So if you had to find that file, that's where it is. And that's why I didn't have to do it. Okay. Next step is adjusting the video times to match the data times. So now we're going to start using that movie times file. And basically, this is one where if you don't have timestamps on your data file, like old CATS files or older, or if you're using a GoPro or some other kind of system, there is a structure in here in this sync vids and data. This is a complicated script that does have an ability to use that header file to sync up your server feeds and data. We won't be able to have a chance to go through that today because we want to stick with the example file, but that's what I want to do. Yeah, go ahead.
We have an error, variable AFS not found. I think that might be if you haven't updated the scripts fully. So maybe download the most updated version of the toolkit from the GitHub, either through the desktop or just directly download it. Yeah.
Or it could be the data file, the mat file structure. If that was created without it, it's not a big deal. That's AFS is just the overall sample rate of your accelerometer. It's 400 hertz for this example. So if you got that error, that's good information. For now, you can just add it in AFS equals 400 in there like that, and then try to rerun this save file. If you got that error as part of your function, just set AFS equal to 400. Set this for now, and then when you run it, if you run it again with updated scripts, that should not give you that error. But that's basically it's the sample rate of your accelerometer at a raw sample rate. So I will make a note that is still popping up as giving people problems. But
and Dave, one more.
Yep.
And this is just so if you're getting something that's saying no recovery time in tag guide, select last movie or audio before recovery. That just means you don't have a tag guide, or your tag guide hasn't been filled in. So the tag guide is this file that we'll talk about later on today. It's store a lot of our metadata about a deployment. So
that also means you're running section 1 right now. So section 1 is what we should have already run the other day. And we're kind of skipping that one for today because from now on we're always starting at section 2, and we're using that movie times file that we already created. So if you're getting that error, you download from our GitHub here. Download that movie times file from our example data, and that's what you're going to need to have as a structure. So that's what's created in section 1. Should moving past that. Is that okay, Will? Does that answer the question? Yep.
Yes, I think so.
Okay. So that was section 2. Section 3 truncated the file. Section 4, it's basically syncing up our VidDN, our video data time. It's also creating these other variables here. At the end, you can kind of always see what it's trying to save and what it's trying to create. This cam-on index is an index of, well, let's run it and then I'll show you. But it shouldn't take too long to run here. Section 4 is done. It spits that out. Basically, now it has these other variables, including cam on, which is an index of when the camera is on. So it's the length of all of my other data. It's the same length as our truncated data file here. So our data table is 766 766,000 lines long. Our DN original is 766,000 lines long. Our cam on is same length, and it's 0 when the camera is not turned on, and it's 1 when the camera is turned on. So it's just an index of when our camera's on. So it helps us keep track of when the camera is on the whale. So that's what's using there. Again, like those are things you don't have to know necessarily right now to run this script, but those are what it's creating. Audio on is similar. Audio on is set up for us. It's only when you have audio that's not also on the camera. So it's separate than the camera on. If you want to know how long the overall audio is recorded for, you'd want to have cam on and aud on switches. VidDN is the timestamp. DN, remember, is our MATLAB date number. It's the timestamp of the start of each video. So it's the length of our video file. VidDN is 18 cells long, and each one has the start time. Remember to look at those. You can do date string, a VidDN, any one of those, and that gives you the timestamp of that video number. And then VidDirs is the durations. That's the duration of every video. And so that's just in seconds. It's how long each video file was. So audio 1 was long. Video 2 is 593 seconds long. Audio 3 was only 10 seconds long because there's just a small gap while the camera kind of cycled recorded audio, and now it's back up, and now we have a 30-minute video, 1800 seconds, and then another 30-minute video, and then a longer, what was that, 25 minutes or something. Cool. Okay, so far so good. So that's what's being created in that file. Those are my outputs that I'm trying to do there. It's also creating this basic tag slip variable. Now tag slip right now, it's nothing. It's just like, okay, it's just 1, 1. It's just an initialized variable. But if you had put information in our header file, that would be reflected here. That would be like, okay, the tag slip index of when that tag slip's happening based on the video times that you put in, that would be recorded here of when you think that tag slip is. So that is not, we don't have one in our file because we didn't put any information in there, but it's there. The GPS right now is just that GPS information from the header file. Whale name is got from the header file as well. It's my index. That's my ID number of that whale name. You can call it a whale name even if you're using a different animal. It's just a MATLAB variable. And then you have, that's the basics. There's some other information in here. Vid data just kind of has that all structured in there. All good, Will? Questions?
Yeah, so there's one question in there too, and let's also give people just a few minutes between each in case they're running through, and if any other questions come in, because I think
Yeah.
But the one question we have there, what about events that happen without video on?
Yep, great. Yeah, so tag slips that happen without the video on or that we don't see in the tag slip, we're going to account for those in, I think, step 7 or step 8, 8A. And so we'll get there. We're not quite there yet. This is just right now importing any of our metadata, our video data, our kind of overall information. So we will get to those tag slips soon when we're using accelerometer data. This is just if we happen to see one that can give us a really precise value.
Yeah, maybe we'll give people a minute or 2 or 3 if people are going through, and give people some time to come up with some errors if there are any. Okay. A question, when I try to run section 2, I cannot select XLSX files when I'm supposed to. Any ideas on a Mac?
Yeah, I'm not sure, unfortunately. I think you'd have to, unless someone else has an idea for that. It probably is just not asking you for that XLS file because you can't see the data. The first thing would be to select the MAT file. It should ask you for 2 files. First, select the MAT file, then the XLS file, even though it's not telling you that in the MAT version.
Yeah, and that's something I've tried to sort of outline that in the wiki, what it's asking for at each step, just in case it's not showing it, which we're now seeing is the case with Macs. So yeah, if there's anything that's not clear on the wiki about that, of what it's asking for, let me know and I can update that. Yeah, beyond that, I'm not sure either. And then we have another question. If my data files have 150,000 fewer lines, did I truncate it differently than Will? 150,000 fewer lines, that's a decent amount of data.
I mean, it could be fine though. Like if you have,
Yeah.
if you truncated it and you still have your whole depth profile when it throws up this new figure and it still had a whole depth profile there, then you're fine. If you're missing parts of this depth profile, then yeah, you might have over truncated it.
So how about this question? How many lines of data are in one of these typical CSVs? Or what's,
well,
is it usually a half hour of data? Is it 15 minutes? If people truncate it to 128.
I think this question is about the data file though, right? Not the CSVs. So this part. So this data file will the length of this data file will depend on the length of your deployment. This is your whole deployment in here.
Oh yeah, okay. Okay.
Same question with OFS. If for some reason it's not saving appropriately in your maybe there's an old version of import cats data running around. If it's not saving that OFS effectively, just add that in there. Add that variable in there now when you're running section 3. So AFS, if you're getting that error, add 400 in there. OFS is the original sampling rate, the original frequency. So OFS should be 50. That's the sampling rate of our data file. So I'm not sure why those errors are coming up in different things, but if you're having those problems, just add in AFS equals 400, OFS equals 50, and go ahead and then resave that. Just run this last line to save that piece. That's where you're getting that error though.
In section 3.
In section 3, if you're having that section 3 error.
Cool. Okay. Are there any last questions? If not, maybe we can start moving on to section 4. Or
section 4 I didn't see many errors crop up for section 4 yet for people. It's just running the workhorse script here is the sync vids and data script. As long as you have cameras there, it's running that script to sync the videos and the data files. And then it just gives you this updated viddn file, this updated vidders file, this no cam, this cam on and odd on. No cam is just like a flag. It's because we have data sometimes with weird data, and it's just a flag that's no cam is true if you have no camera. No cam is false if you do have a camera. So a little counterintuitive, but there it is.
The file for the select metadata text file with sample rate information, that should be the header file, correct?
If you're getting that error, yeah, it again is something that wasn't saving right in your import cats, but it's just this text file that has all of the sample rate information for your data. So you point, if you're getting that question of okay, point to that metadata text file. That's this text file in your raw folder with the text file here that has all of the interval information in there. So that's part of that, finding that sample rate information.
Cool.
Yeah, good questions. Yeah, sorry. I think this is I think it's some versioning issues, but we're getting there. We're so far so good. So those are the pieces of information you need. AFS is 400, OFS is 50. If you had those errors, it's asking you to point for that the metadata file. It's this text file in your raw data. It has all of that information in there. And that's just reading the sample rate information. Cool. We're basically set up here now so that we're loaded with the data that we're going to use. And from here on out, now we're starting to manipulate and adjust our data. So we're still operating in kind of a raw data format. Basically, we don't have any main variables yet. We have this data file, which has all of our data in there. And we're still kind of operating with this as our main structure so far. And we're going to start breaking that down here in a second. We're still also operating at 50 Hertz at this point. We have that OFS is 50 Hertz at this point. So eventually we're going to downsample that. I should have mentioned that actually earlier on. In step 2, one of the at the beginning of every cell are some variables you can set. Usually if you want to check anything okay, if it's section 4, if I don't have video timestamps and I want to run that switch where I don't have videos, I would set this to false. If I don't have a camera, I would set this to true. Those kinds of adjustments you would make to your own data file. In section 2, when you're running this, the very first one you set here is this decimation factor. The decimation factor is how we're going to take, whatever data you were sampled at, if you want to make that so that's a more reasonable size, because you don't always, we sampled the data at 50 hertz. Most of the magnetometer and gyroscope data is all sampled at 50 hertz, but that's a little bit bigger than we actually need for most of our purposes. So our final PRH files are usually saved at 10 hertz. So we decimate all the data using Animal Tools, Mark Johnson, Stacy DeRuyter script to decimate the data to 10 hertz. So our decimation factor is 5, because we go from 50 hertz down to 10 hertz. So we decimate by 5. If you've only collected data at 1 hertz, then you're probably not going to want to decimate it, and your decimation factor would be 1. If you collected data, all your data is at 400 hertz, you might want to decimate it by a factor of 40 or something. So it just depends on kind of what your final purposes are. For our purposes, most of the work we do, we found that 10 hertz works pretty well. It gives us really good resolution of the data without being a ginormous file. So we tend to decimate down to 10 hertz from whatever the data is. If it's collected at 25 hertz, we'll put a decimation factor of, well, it needs to be an integer. If it's collected at 30 hertz, you decimate down, you put a decimation factor of 3, etc. If it's collected at 25 hertz, you might either leave it at that or decimate by 5 to get it down to a 5 hertz file. Depends on what you're going to be your useful factor. So that is something that you guys will set based on your data collection. We've had some errors come up associated with that last night, and you can import CATS data at different sample rates to account for that as well. Okay, so far so good. Didn't see all the new questions come up, but we're looking for everything. Okay, so now we're going to start doing some work with our data. Now we're going to run this tag on and tag off script, and we're going to have this result be a kind of our canonical tag on, tag off times. This is the same kind of script that's run as part of the import CATS data, but this time we're going to like save the results. So this is at the beginning of every file is kind of this like load options. And this is just so that if you can restart it if you don't have it, but it's okay to run this even you're running these files even though it says load in here. It's just going to reload these files that have already been saved in my info file. So there's this info file now that's starting to fill up with data. So it's going to load those information first, and it's going to use that as part of this script. And that's kind of an indicator of like, what is the data I'm going to use in the script? So it's going to load those files. And at the end, all we're going to try to get is this tag on variable. And this also this flag that's like in some bad data. If you don't have pressure sensor, we want that flag in there. So it's basically giving me this data file here. Basically, my instructions are down here on the left here. I get a left click to change a boundary and right click to zoom in. And so I'm going to try to get my tag on and tag off times. And the reason it's set up like this too is we have had deployments even where the tag falls off an animal and we put it back on the same animal. And so you might have multiple tag on and tag off sections. But in this case, we just have the one. So I'm going to zoom in, I'm right clicking, and you can see this accelerometer with this really big spike here where the tag right went on the whale. So I'm going to set my tag on time just slightly after that. And I'm just going to keep the data just slightly after that big spike there. And everything after that is assume that the tag is on the whale. So that's my spike there. At the end here, so that was pretty close. That was just an automatically generated yellow box here, but it was pretty close to the beginning. At the end, it's a little bit off. So I'm going to zoom in here at the left, on the right by right clicking. You can see that my yellow box here goes all the way to the surface. Well, the tag actually came off much earlier. Here, the tag is just like spinning around in the water as it goes up to the surface, and it's just slowly ascending to the surface because luckily they float. But here, the tag probably came off the whale right here. And this is kind of like one big fluke stroke here at the end where it's just kind of getting kicked around. So I'm going to set my tag off time a little bit before that fluke stroke because I don't need all that extra data. So I'm going to set my tag off time right there. Just click left clicking right there. And that'll set my boundary there. And you can see it's a little bit off there. And that's it. And I'm going to press enter. And then that'll save my tag on variable. All right. I see no questions or errors popping up for people. Hopefully everyone got there.
Yeah. Maybe let's take a few extra minutes now just before we move on. Just to see if any other errors pop up, if anybody wants to head into breakout rooms or anything like that. I'll be starting with the next section, so I have to go and download this info file as well. So we'll go through that a little bit.
Yeah, actually, well, let me put them on there because I made them from a different thing. So I'm going to put those two files, the info and the truncate. So we're all kind of, if you want to, you can keep working from your own file right now for now. I'm going to put these two in the Google Drive, and we'll take a break here while Will gets set up so now he's going to use that same info and truncate file from here on out to basically restart the process. So let's say, oh, my MATLAB crashed. I have to restart it. It's okay. Like we're gonna be able to restart that process right now.
So question. There's a question and then one error that we should go back to. So a question for determining tag off time: do we use the cam video to confirm tag off time, or rely on changes in accelerometer alone?
Yeah,
yeah.
Go ahead, Will.
No, if we have video and we can see when the camera comes off, then yes, we can use that to sort of confirm where it's happening. Yeah, but we don't always get that.
And oftentimes, just in general in deployments, like the camera is going to last less long than your data is, or even probably on the whale. So often your tag off time will be at depth when the camera's not on, or when after your cameras have stopped recording because the data's off. So just to be consistent, we generally just use the accelerometer information, and it's a pretty clear timestamp. So you can usually see it from that depth profile in the accelerometer. But you can, yeah, if you have it on camera, good idea to confirm that. So my data is uploaded, Will, so you should be able to download that truncated info file.
Okay. And then we had one error from a little while ago. From the making the truncated file, we had an error: unrecognized function or variable data. Would that be an issue, a pathing issue?
Well, a couple of things. So yeah, if it's not finding data, that means, yeah, you don't have this mat file. That data structure is in this mat file. That's our main structure there. So it means we didn't point to that file originally well. So whenever it's trying to load that at the beginning of every file, it should be trying to find that file loc and file name. That should be trying to find that mat file. And so when you need to run section 2 first, to whenever you're starting to run section 2, so that you can tell it where to look for that file, and then after that it should load that file effectively. There was another question down there. So that so we just did this tag on and tag off time. Is that saved effectively? Yes. So that is saved in my info file. This tag on variable is now saved in that info file, and that tag on variable is just this logical index, just like the cam on, that shows me, okay, the tag is not on the whale. Okay, now it's on the whale, all these ones, and then at the end of the tag, it's a 0 again, and the tag is not on the whale. So it's just an index. True or false is the tag on the whale at this given time. So that is saved in the info file.
So let's just take a few more minutes while I'm getting this set to go.
This is good. Never PRH in front of an audience before. So at this point, our info file should be filling up with data. Our truncate files, which is a little bit shorter than the mat, and Will and I are just syncing that up. So we're going to use the same truncate and info file, so we have the same structure moving forward from here. And Will's going to basically go through the applying the calibration sections. So we've imported our calibration files in here, which is our calibration structure. And Will's going to basically now apply those to the data so we can start pulling out actual variables from the data, including pressure and our structures AT and MT, which are going to be our kind of our workhorse accelerometer, magnetometer variables. And he's basically going to apply a calibration, both a calibration from the bench test and an in situ calibration. A calibration based on like, okay, well, my tag is in the water. It's in really cold water. Usually the water is colder than the lab environment that you did. Maybe if you're somewhere else, it's warmer, but where we work, it's mostly colder. And that affects your calibrations. And so we're going to use some of those animal tools, animal tags tools from Mark Johnson and Stacy DeRuyter and Ann Allen to calibrate that data in situ. And so it's kind of a setup to do those scripts. Let me know when you want me to stop sharing, Will, and pass it over to you.
Yeah, give me 1 sec here.
And it's a similar kind of thing. So what Will's going to do now is he's going to start from scratch. He's going to have a section. He's going to start from section 2 and import the data, tell it where to look. And then he's going to skip ahead. It's going to tell him that, okay, you can start at section 6 because you have your tag on variable saved. So he's gonna skip ahead to section 6 and start here. You guys don't have to do that. You don't have to clear your workspace and start over again. You can just keep going. But if you want to play along, you can clear it and start from section 2 and then section 6 as well. You can do either one of those options.
Okay.
How do I move forward from figure 41 after you selected the boundaries for tag on and tag off? Press enter. So once you're tag 41 and it's asked you to make that figure, just press enter and then it'll save that tag on, tag off time. Cool.
All right.
You ready?
Preparing now. Yep. Okay. So let's see if this works. All right. Try to make this a little bigger over here so I can see some people. Okay, good. All right. So I'm in my MATLAB now. You can see I've got my path. I've got my tag data raw folder here for this deployment with everything that Dave was talking about before. So we have our mat file, which is kind of what I'm going to be starting from again. We have this info file that we've been making, the movie times file from step 1, the truncate file from step 3. Ignore this. I was just testing out a PRH last night and just made it to make sure that I can actually get through this. Okay, so what I'm going to do, like Dave said, I'm going to basically, assume that I worked on this yesterday and I got through step 5 and everything, worked out through step 5. And then, I had to leave for some reason. No. And so, I'm coming back to it this morning and I'm trying to start at step 6. I don't want to have to go through the whole thing again. So what I can do here, let's get back up to the top. So again, we don't have to do cell 1. So we're going to start at cell 2, the select files. So I'm going to click to run this section. So again, it's going to ask me for my CATS data, that imported mat file. So I have that right here. So I'm going to click to add that in. You can see it's thinking. Okay, now it's going to ask me for my header file, the Excel sheet right here. So I'm going to add that in. All right, so we're good to go. So essentially what it's doing is it's looking and it's finding that info.mat file and looking through that info.mat file to say, okay, how far have you gotten in here? And what it pulls out for us is that we've, created up through step 5, which means, cool, everything through step 5 is done. We can start at step 6. So I can literally just skip down here, skip past all of these, and really start at step 6. So these next few steps are going to be starting with calibration. We're going to be starting to calibrate the pressure or the depth. Then we're going to be calibrating the different inertial sensing units, right? So we're going to be calibrating the accelerometer. We're going to be calibrating the magnetometer in a few different ways. And the idea is these are in situ calibrations. So we're going to be using the data from the deployment to help calibrate the sort of the range of data that we're seeing. So it's calibrating itself in a way. So for step 6 here, the important piece about this step, we're going to be sort of using it to calibrate that pressure and depth, like I said. But one thing to note at the end of each cell, and Dave mentioned this a little bit, it tells you what it's saving into the info file. So, at each step, so if we were to go back to cell 5, right, these are the only pieces that it's saving into the info file. And later on, you'll see there's some other steps where, yeah, again, it's sort of just, it only saves that calibration file or something. But in step 6, which is the one we're doing right now, there are a lot of new things being saved into this info file. So this is a big step for that. So it's really important to run this because it's creating a lot of these different variables. You know, temperature, light, you know, tag on, things like that, the frame rates. It's updating this calibration file. So we're gonna start here if everyone is prepared. Does anybody feel like they need another minute? Would another minute be helpful to catch us up to where we are now, and then we can start? Or would you guys like to just have us go? Awesome. 1 minute. Cool. Yeah. So you know, maybe just for a minute here, I'll kind of talk through what we're going to be doing. And so, you know, the next few steps here, like I said, are going to be these calibrations. But then what are we really going to be doing after that? So we're going to be, you know, section 6 here, cell 6 is part of the calibration. Section 7 is part of the calibration. And that's where we're really doing the calibration of the accelerometer and then the calibration of the magnetometer. That's part 7A and B. And then after that, we're going to start to try to find the orientation of the tag. So right now in our data, the orientation is the orientation of the tag itself, right? So if you stuck this on a whale or a shark or something and it's sideways, currently everything is in the orientation frame of that tag, right? Which doesn't necessarily align with the orientation frame of the animal. And that's what we need to do. So part 8 here, you know, part 8 and then cell 8.2 as well, sort of all together. They're gonna allow us to really find that orientation of the whale and then create a rotation matrix that allows us to switch over the orientation frame of the tag into the orientation frame of the whale. And so we're going to use that, we're going to do that using the period where the whale's at the surface, right? Because we assume that when the whale's at the surface, the whale is level for the most part. Obviously that's not always the case, but we want to find periods where that does seem to be the case. And then we also use the segment either right when the whale starts to dive or right when the whale is coming up from a dive and starts to sort of transition into a surface. And the reason for that is because we essentially at those times, we assume that it's a pure pitch, right? So we're not getting a lot of crazy rolling when the animal goes for a dive. We're not getting a lot of crazy heading changes. The whale is essentially just going from flat and level to pitched downward, or if they're coming up from a dive, they're going from pitched upward to flat and level. So we can use that to sort of get a sense for, okay, what would the orientation of the tag look like if it was, you know, transitioned over into this whale frame or this animal frame. And then another piece of that, if you get the tag slipping around a lot, this is something that Dave talked about earlier, that you have your tag slips that sometimes you can see them in the video, but not always. So this is also the step that allows us to find those tag slips and really, you know, figure out exactly where they are and then create sort of these calibration periods around those tag slips. We can calibrate it when the tag is faced like this. And then if the tag slips, well, okay, we can recalibrate everything again. And then if it slips again, we can recalibrate it again. So it's pretty robust for the tags sort of moving around a lot. Okay, so I think if we've had enough time here, let's head back up and sort of start going through this a little bit. So I'm going to run cell 6 and I'm going to hope that it works. Let's see. So I'm going to hit run and advance, which just sort of pops me down to the next cell once it's finished. Oh, here we go. Air and pressure cal plot. Ooh, there we go. Fun. Forgetting something, Dave.
Yeah, it's probably because we tried to switch this off. So if you have an older version of did you download the truncate file too, or no?
Yeah. Okay, well, let me get back to it. Let me try it again.
Probably because we tried to switch these between people.
Yeah, we tried to get the new one. What do you want to try to do? I can re-download them.
Well, let me. Why don't you try it, and I'll go back to running it off of mine for now, just so we can kind of keep moving forward. And then if you can figure it out, then we'll go from there.
Cool. Yeah, I'll keep running.
Okay. Sorry, I thought that was a good idea, but we'll go back. We'll try to figure out where the issue is there with because it's when we truncate it, we're changing the length of the file, and so that's throwing that error where you have this problem with the data there. So so people running this file, and right away I see some errors coming up with the world mag m, or maybe even with no press. So let's, if you're getting that error with no press, set no press equals false, and we'll set that to make sure that that's the default in there. Oops, that's the wrong MATLAB. That's why I'm getting that error. Okay. Go back up to section 6 here. Okay, so running this part. Some people I saw so what it's trying to run first is this world mag m file. If you can't, if it's giving you an error in there, it should catch that error and give you this warning that it needs to find this the declination and inclination and B. So this is the magnetic field. So world mag m is a problem that it just throws errors sometimes, and I haven't figured out why. In some people's versions it does, and some people it doesn't. So it's a great function. It tells you the declination, inclination, and B. So there's different versions in different MATLAB, and we've tried to put in a version in the script that should work, but some people it still throws errors. So if you get that error, you just have to look up on this website where your inclination and declination are. Go to this website that we showed you guys yesterday. It's just this one. And look up, put in your latitude and longitude from that metadata file. It's like -66 and -66, and then it'll spit out for you the declination, inclination, and B. So I'm seeing that people crop up with that error. Mean sea level. So let's just put in. We have to put in 66 and 66. It's south and west. And so if you calculate that, and again, like these aren't going to change that much. It's not that big of a deal, especially for today's purposes. But we can put in the actual day here, so March 12th. And we can put in March 12th. And then you just click calculate in that magnetic field, and that'll spit out your declination and inclination and total magnetic field strength. And so you're trying to put those in here in degrees, inclination degrees below the horizon, and magnetic field strength in nanotesla. So that's all basically exactly what is spitted out here. So you have your declination 17.5 degrees, -58.2 inclination, and total field is nanoteslas is 39,000 nanoteslas. So if you got that error, then you should spit that out. You should be able to input those, and then it should be able to move on. Once it does that, it should actually spit out for you a image with a pressure value. Nope, just going through my figures here. Oh, what are those? I'm getting the same error Will did. Good times. Hopefully other people are probably getting that same error. That's wild. Okay, I think what it is, we'll do a quick error check here. This should take a second. I'm going to plop in here. I'm going to say, this is the way we do in error checking. So db stop both of this us ran this yesterday, so I'm not sure what the error is. So we're gonna run db stop if error, and then we're gonna run in here this. It probably has to do with this because we're running this multiple times with different truncated files. I'm sure it has to do with that. But we're gonna run this now. We said, okay, we're gonna stop it on the error. So I'm gonna run this file. It's gonna stop where I get this error. It's saying that my DN is one value less than my depth. So that's weird, but okay, right? I don't exactly know where that's happening right now. So for today's purposes, if you're getting that error, basically we just need to adjust our DN value so that it's one longer. Well, let's see. So everything else is at, so let's see what our normal values are if DN and depth are, they're saying they're at different lengths here. So that's why I'm going to quit debugging. I'm going to go back out to my main screen here, and it's just basically inputting this DN value, and it's my DN is basically different length than, which is one shorter than my data file. Than my decimated data file, which probably has to do with the way that depth is decimated. So I'm going to add in one, it's basically here. So it's just decimating it. Funny. Apologies. Going to, let's take a quick break. 5 minutes, go to the bathroom. Let me fix this. We'll come back to it. Let's take a quick break. Then I'm not sitting here in front of you guys. So 5 minutes, we'll come back at 11:21, and we'll have the right DN here. It has to do with how it's decimated. And of course, it's the one example as we do things in a slightly different way. So let's just figure out where the decimation problem is happening, and then we'll come back to you.
If there are any other questions or problems too, on maybe some of the first steps, I'm happy to head into a breakout room if anybody wants that.
Yeah, it's just a problem with that. For those of you guys playing along at home, there's a fix for the pressure cal script up on top on GitHub. You can download that. I can also, it's only a temporary fix because it's not an elegant way to solve this problem. But I was also thinking about right now how to solve it for today if you have trouble downloading the scripts for today. So one way to fix it is to download that script, and another way I will give it back. I will give you an idea here. Basically, yeah, okay. Basically, I'll just give you the fix. Basically, for today, if you, here, I'll send it to you here. Share screen. So you can either update your GitHub or in the, where's my chat now? So there's a new line here. You can copy that from the chat. It goes in line 23. It's basically just an error of the pressure cal script. So if you open pressure cal, you don't have to even look for it. You just do type open pressure cal. And then in line 23, just going to add this check here, where basically the depth variable was one longer than my timestamp variable, my DN variable. And that was happening just because of how it was decimated, because we haven't run any of these new scripts enough yet. And so we have a situation where there's like an odd number of rows in my cell. And so it's decimated it to a different length than how it was decimated for the DN. So we will we'll check why that is, and we'll come back to it. So for now, it's just this fix in here, which isn't a very elegant solution, but it'll work for today. So I put that in the chat, that line. So you can just copy that line and put that right into the pressure cal in line 23, or update from the GitHub, and that'll allow that cell to work. And that was the same problem Will was having. So at least we solved that. So I can go back to, we'll throw this back to Will as well to run this after Will's able to do this. I think, is Will still on here, or is he in a breakout room? Will, are you with us? All right. Let's send Will a message and then we'll come back to it.
Hey, Dave, I just missed the first part of that. Sorry. So
no worries. I'll send it again.
Should we put this line in regardless, or if we didn't get an error, should we still include this line?
If you didn't, yeah, that's a good point. You might not have gotten an error because you truncated to a different value than we did. So you might not have gotten an error. That's great. If you didn't get an error, you don't even need the line, but you can put it in and it won't hurt. It's just an if. It's checking if there is that error exists. So excellent point. Yours might have worked just fine because your truncated was just to a better value to truncate to. So good point. Another fix, if you had gotten, that brings up the idea that if you had gotten this error and you didn't know how to fix it in your code, you could have just gone back and retruncated it to a different value, and hopefully it would have worked out better with the way that it worked out. But good question. You do not need to fix it if you did not get the error. But that is that fix. So I'm going to go ahead and move forward with this, because I think everyone's waiting here and everyone's with us. Basically, to run this section now, we're just going to run this whole section again, run section 6 to run this pressure calibration. And it's basically asking you a question here. And hopefully everyone else is able to get to this point too. And if there's anyone who needs me to pause, you let me know. But we're getting to this section here, and so basically it's plotting both the bench calibrations, which was not very much, and this in situ calibration using the temperature values of the pressure sensor. And if you zoom in here, you can see that the bench calibration is a little bit off of 0, right? It's like that's not quite at the surface. It's like -1 or -2, and the in situ calibration is a little bit higher. In situ calibration ends you right at 0 there. So we're going to use that in situ calibration. So it's asking you on the main screen here, do I want to use the bench cal or do I want to use the in situ cal? Almost always you're going to want to use in situ cal, but it depends on how your data is organized. Maybe there's actually, even with the in situ cal, there's still an offset that you want to account for. And that offset could be because the tags actually spends most of its time not breaking the surface. It never really gets up to 0 because it's down on a side of your animal that never gets to 0. So, and maybe a calibration was inappropriate for that. So there could be all kinds of reasons why you want to add an offset. For now, we're just going to accept that green value, that green bar. So we're going to move on from there. So the in situ calibration was chosen. And then it's going to spit out basically my raw value. So now we have these two raw variables here, the MT and the AT. The MT is our magnetometer in tag frame, and the AT is our accelerometer in tag frame. So the accelerometer in tag frame, so that's basically that. It's our three values. The black lines are the overall magnitude of those values, just like Will talked about yesterday, is the overall magnitude of the accelerometer and the magnetometer. So the magnitude is should be in the accelerometer, if the whale's not moving very much, should be approximately equal to 1. So that our bench count for the accelerometer is pretty good so far. We still have just this accelerometer value just approximately equal to 1. The magnetometer, not so much. And the magnetometer is much more variable. That's why we're going to do this next step to get that better. Like we want this to be a flat line ideally. And using our bench calibrations, it's not so great. And that's partially a temperature offset. It's partially a factor of the camera. It's partially a function of how these sensors kind of change with temperature and warping over time. So there is a variation here, an offset variation. You get an unrecognized cam on variable. That's interesting. Hopefully, you should have that in your info file. So if you're having that problem where you're not having a cam on file, I just see a question that says someone's having a problem with their cam on variable not showing up. That should be in the info file. So if that might mean that you didn't run section 5 earlier or section 4 earlier when that cam on file was created. But you should be able to check that your cam on file exists. And if you see it in your workspace, then you should be fine. If you don't see it, then you can either go back and run section 4 again, or you can try download the info file from the website that we've been working with, so that should have that cam on file in there. Although you would have to use the truncate file that we used as well. So double check that your cam on file exists if you're having that problem. Okay, great, thanks. Glad we found that. Okay, so section 6. So that's what section 6 does. It creates that pressure calibration, and then it kind of spits out these other variables that are going to kind of be our main values. So including this AT and MT, which are kind of our workhorse scripts. So that plotted out for us. Okay, so the next thing we're going to do is actually calibrate AT and MT so that they're actually real. So right now it created this like AT bench and MT bench, which are kind of like, okay, just using our bench calibration files. We created that AT bench and MT bench files. And those are, oh no, I had an error. Weird. Yeah, so we're getting that same error in here. So what I'm going to do is I'm going to go back because we're getting this error and other people aren't getting this error. I'm actually going to go back right now and just going to rerun from section 2, and we'll just choose a different truncated file for our data, and that'll help clear up this error, and I'll know to go back and fix that for now. But that's what I'm going to do, and so let's take a second here. But we'll go back and we'll just rerun from our raw data file from step 2, and that'll give us a chance to catch up too. So other people shouldn't be getting these errors, hopefully. But I think it just happens to be the one that we selected. So if you are getting these same errors, I'm just going to go back and rerun. I'm going to delete my truncated file that I created and kind of rerun from there. So starting with section 2, I'm going to select my files. That's my folder here. I'm going to reselect my file, select my header file created there. I'm going to retruncate my file. It'll take a second to save it, but I'm just going to select the default values here instead of trying to retruncate it. And that should give us a better file. So there's not much to do here. I'm going to retruncate that. It'll get us a better file. And just to update you, Will, I did fix that one section, but it's going to keep coming up with that error because of how it's decimating files. So I'm just redoing it from step 1. So now we have a new truncated file. Run section 4. That'll just take a second here to sync the video and the data. I do have, Taylor asked earlier if we can run through that. I have an example queued up to show how to do that without timestamps. We'll do that later on. My tag on, tag off times. It's going to quickly zoom in here. Select my tag on, tag off times. Tag on right after that big spike, tag off right before this big spike. Press enter, moving on. And now we're going to be caught up here. Section 6. Okay, section 6. When you use, like we just talked about, we're going to use, we like the second one. When I zoom in, I like that the green one is up on 0, that in situ calibration. So I'm going to select section 2. And now we have our values here with our, this is our pressure sensor. This is just the temperature value over time. That you can see that this is in the Antarctic, so the temperature doesn't fluctuate very much with depth. You have your MT and AT here. So then we'll run section 7. So section 6 is now finished. And so section 6 created all these pieces, no errors there. If anyone's still getting errors, please let me know. But if you go back and if you're getting that same error with the truncated file, if you go back to step 2 again, just like I just did, delete the truncated file that you had made and just say accept the default values. That should get rid of that error for now. And I'll note to go back and like make sure that that's going to be more robust for choice of truncated. But for today, if you just go back and accept the default truncated values, so delete this truncated value, go back to step 2, run everything again, and you should be able to catch up to running section 6 here. And just like I was saying, it'll create this AT bench file, which is our bench calibrations, and our same with MT bench calibrations. Out of that, some of them out of that line of code. I think maybe when you add that line of code, you have to make sure to, if someone said they're getting that error, they're trying to add the code that I added, which we don't need anymore, but make sure to add all the way down through this end. If in the chat, the code kind of goes over from one line to the next. So you have to make sure to add both of those, the whole thing, all the way down through the end. So it should look like this whole line of code that also goes all the way to the end. But I'm just kind of pausing to let people catch up if they had to rerun the truncate. But we should be good. We have created this decimate and apply cal. We're starting to create our decimated variables here, and we're going to go to this in situ calibration. So Will, if ever you catch up, I can switch it back over to you for these. Other than that, I'll kind of keep moving forward with those.
Okay. Yeah. Let me.
If you just go through and delete your truncate file and select the default values, and then you can go through and we'll turn it over for you for the tag slips.
Okay, sounds good.
But for now, we'll run section 7A. So now we're starting to actually apply an in situ calibration, like Will was talking about. This is basically taking our pressure values and our pressure data and applying calibration data. So it's going to take a second to run, because what it's doing is it's trying to really adjust values to get our values closest to 1, maximum value magnitude 1. And for MATLAB, one of the things that can be hard to tell is that if it's working or not. So you have this, if you have this in newer versions of MATLAB, all it does is it says busy down here. And that's kind of your key that you know that it's running, is that it's staying busy. And besides that, you have you can also always come into like this main command window, and you can just like type a quick equation or something, +1 + 1, and if it doesn't spit out the answer that right away, it's because it's working on something. So right now it's busy. It's trying to answer this. It's trying to do this calibration script, and it's basically the main workhorse script here is this cal A, and it's basically taking that raw data, taking your tag on variable, taking all your sample rate information, and spitting out this structure with this information. So it tried once, and it says this cross method cannot converge. And so that's going to be typical. That basically means it's trying once with no outside information, no bounds, and it's trying to just do that whole calibration. And then it says, okay, well, that's not going to work. That's just too unstructured for me. So give me a few bounds. And what it does is it tries again with bounds, basically saying like, oh, my accelerometer can only be between -3 and 3 or something like that. So that it has like a minimum and maximum value that it's trying with. And at the end, it should spit out a plot that looks like this, where you have your raw accelerometer values, your bench cals are 3 different colors, and then laid over the top of them are your calibrated values. And for an accelerometer, this is what we want, where that they don't look that different. So that the bench calibration and the in situ calibration are pretty close, because our values are pretty close to 1. But our spherical calibration or in situ calibration is still a little bit better. You can see that it's closer to 1. So in my accelerometer magnitude here, the 1 is indicated by that like flat line. The blue line is our bench calibrations, and the red line is the spherical calibration, that in situ calibration. And you can see that it's a little bit better. It's a little bit closer to 1. So when back in our main screen, when it asks you what do we want to use, we want to use that spherical cal. You type in 2. Which I guess I already did because I put in the 1 + 1 equation, but it spits out 2. You want to spin in that spherical. You choose that spherical calibration, and then it'll finish that section. It's going to be the same thing, and then it's saving that calibration in my info file. So my info file continues to be adjusted here. My info file continues to grow. So far, so good. 7B. We're going to run the same thing. This is also going to take a little bit of time to run. So I will just describe it as it's running. I've clicked run section. So it's starting to run. You can tell that it's busy down here. And it should come out with this. Basically what it's doing is it's calibrating the magnetometer using that same procedure, doing that spherical calibration. Now the values that it's spitting out here, just so I can kind of go over them with you, it's this residual and this axial balance. Like you generally don't have to pay too much attention to it. Oh, that's quick. But what it's giving you is you want residual to be low. The residual is how far off you're from, on average, from your expected value, expected overall magnitude of the field, whether it's gravity would be 1 or the magnetic field is B, that magnetic field strength. The axial balance you want to be high because it's saying, oh, how much did I rotate through all my different axes here. And so for the magnetometer, you have these really nice rotations as the whale lunges and spins kind of naturally. So you have these values that ends up being a pretty clear, pretty close line to our value here. And if you remember, compare that to our original bench calibration here, this spherical calibration is much better. It's much closer, much flatter line as the whale goes through its normal motion. So as the magnetometers interact with each other, you're getting a better, flatter line. It's still not perfect. Because it's real data, because our data looks like that sometimes. And the sensors are not quite going to be perfect. But the magnetometer is pretty robust. So for purposes of calculating the heading, you're going to be really accurate with these values because the point is how they relate to each other. So this is going to give you some really good, nice values here. So are people having those problems? I don't see a lot going on here, but this difference between the spherical and bench calibration. The bench calibration, the spherical cal is a type of calibration. So for the bench calibration, we did it outside. Will rotated those tags outside. We had that initial value, and that kind of gets us started and gets us close here. And then we want to do these in situ calibrations using that same spherical cal method because the environment is different than the environment at the lab. So we kind of take our initial bench cal as a starter, and we run our spherical cal on this. If you do have a tag where you weren't ever able to bench calibrate it, you might be able to get a good spherical calibration without having a bench cal file at all, but it's just safer and better to have a good bench calibration as a starter file, and then you can use this calibration file after that. It'll work a little bit more robustly. So the spherical cal is the in situ calibration is this new one down here. Yeah, sorry for the vocabulary mix-ups. Okay, so far so good. We've got those calibrations all set up and good.
Maybe let's give like 2 minutes and we can move on to part 8. I'm all caught up with you, Dave, so I can take over for this one if you'd like.
Sweet. Why don't you take over from this one? Everything should be the same, so I will stop my share.
So we'll just maybe give a minute and a half without a share.
Now we're going to get to the good part. A lot of clicking here. A lot of there's going to be some variation in the next part for what exactly your values are going to be. Like our values are not going to be the same as what you select, but we're trying to give some information and guidelines for how you'd pick this information. So this is where tag PRH can get to be a little bit of an art because it's it's going to be different for your deployment, and you're kind of making judgment calls. This is where like it's not easy to just say like one script or one procedure for everything. So this is the rest of this part is a little bit user interactive, because it's going to be some judgment calls that you're making. So we'll try to give you some information for how to make these judgment calls. But in the end, it's going to come down to like, to kind of thinking about, well, what's going on and what are my variables and how does my data end up looking? Do I get a nice calibration out of this value? And this is where, like, if you knew exactly where the tag slipped because you saw it on camera, that can be useful. But if you only have the accelerometer, we're going to try to do our best to interpret the accelerometer here in this next section. But it is like some interpretation. It is where this is where we turn into so in the SoCal BRS project, where these behavior response projects, they used to do a lot of presentations for the navies, and they would present all of our data, and then the Navy people would say like, oh, it looks like you guys are doing some arts and crafts there. So this is the arts and crafts portion of the tag.
We got a question in the chat. Trying to recreate my info file, rerunning section 4, and I get an error, unrecognized function of variable vidnam.
Yeah, that's the video names. That should come from the movie times file. So hopefully you should be able to run those with.
So potentially, if it's not working, download the video times file from
movie times file, yeah.
Drive, or the movie times. Okay.
Partly, some of the errors with like finding the variables might come from making sure we have the structure, like all these files in the same folder path, so they can find the info file and the movie times file and the truncate file and the mat file all kind of finding from the same folder.
Error in 7a, undefined function or variable tag on deck. Tag on declination.
Decimated, tag on decimated.
Oh, decimated.
Yeah. It should have been saved in section 6. So when you ran section 6, it should have saved the tag on dec. And if you had an error earlier, if you weren't able to finish section 6, then it maybe that was the problem. We need to run back and figure out what your error was in section 6.
Yeah.
And again, like if you're having individual problems, if you're not able to follow these, we will have the session this afternoon too, and we can go through and figure out exactly what's going on in your data. So we do want everyone to be able to run through this exactly using this example file from start to finish. So if you're having individual problems and you can't, if you're having problems, if you feel like something's keeping you up, that's just that's not clear, then we can go over that this afternoon as well. And I'm happy to just like screen share your screens and go through the whole thing.
Definitely.
Even if you just get the concepts right now, then it'll be good.
Cool. All right. Well, I'm gonna, I think, start on section 8 here. So I'm gonna share my screen, and we can, as Dave said, we can start the arts and crafts portion of the show. Okay. So I've got everything going here. Okay. All right. So part 8 said this is going to be finding the slips. So we're going to run that. It's going to pop a window up here. So, okay. So in this window, what we're seeing, we have the depth profile on the top here. And then below we have the sort of the average of the X, Y, and Z values at the surface. And this is sort of in the tag orientation frame. So essentially what this means is, if you see a big jump in these axes, that usually denotes that there was a slip nearby, that the tag slipped from one position to another, because all of a sudden the tag's orientation at the surface is different than what it was before, if that makes sense. So what we're going to go through here and do, so we have our black lines, which are our tag on and our tag off times at the beginning and end here. but I'm going to go through and essentially, try to look and say, okay, where do I think there might be a slip? Or slips. A lot of deployments, we get quite a few. So I'm going to look here, and I'm going to think that there's probably one in here, right? Because we kind of go from a little more stable, especially with our x-axis, to something that's a little bit different. So I think there's going to be a slip right in here somewhere. So what I'm going to do is I'm going to go over here and I'm going to left click on this apparent tag slip location. And when I do that, it's going to zoom in on this portion here in red, and it's going to blow it up here so that I can see it and I can see what's going on. And okay, so we've got this portion here. I think that there is a slip in here. Sometimes it's really obvious that all of the axes just shift immediately and you go, okay, well, clearly there was a slip there. But a lot of times it's a sort of a more gradual process. The tag will sort of start to move and then it'll get pulled by the water. And then all of a sudden, a minute later, you look at the video and you realize that it's completely different, the orientation.
Question here, Will, can you say again why you chose this spot? What did you see on the bottom graph that made you choose this section?
The main reason I chose this is because this x-axis here, and I think, this x-axis here, this blue line, that average sort of shifted. There was a kind of a change in the slope for a second, and then it sort of found a new sort of even point. So,
and just to clarify, on the bottom there, those are the values of the accelerometer just when the whale is at the surface. So those are times when we expect the whale to be in kind of neutral position, where we expect the whale to kind of be set, like it's at the surface, it's surfacing, it's solid. So we expect those all to kind of be the same throughout the deployment. So when that starts to shift, that's a sign that the tag has changed orientation.
Yes. So if here there's a pretty definite shift to my mind in this x-axis. So that's why I kind of clicked on here. And so I think there's a slip in here. And so what I can do is I can kind of look and see, is there anything in particular that seems a little bit off? This seems a little weird. It's a little bit jumpy in this region. With this x-axis kind of jumping around a little bit. And then we have sort of the shift in the z-axis right here that we're really not seeing anywhere else in deployment besides sort of here when the whale is diving. So, although that does line up with that a little bit. So, it's not always completely clear why it's happening. Sometimes what will happen is if the water hits it as it's coming in or out of the surface, like if the tag breaks the surface as the whale comes up for a breath, and then if the tag gets pushed into the water again, sometimes that'll be enough to kind of pop it a little bit and move the orientation. So I think that there's a slip in here somewhere. So I'm gonna say that it's right around this small region here. So I'm gonna look up here for sort of the instructions on this. I'm gonna click 1 to set a left boundary and 2 to set a right boundary. So what originally with this functionality, we sort of assumed that tag slips were like a period or it was a point slip. But that's not actually the case. Like I said, a lot of times these slips can take, a full minute or 2 minutes for the thing to really kind of find its new balance point and its new orientation. So what this allows us to do is really say, okay, I think that there's a slip that starts here, and then I think it ends once we sort of find this new section there. And so if I'm happy with this slip, I can press enter to accept it. I could also right click to remove it if I wanted to. So I could just right click on that and it'll sort of just bring me back out of the whole thing. So let's go back in again though, and let's set that. So I'm going to click 1, I'm going to click 2, So we have our tag slip, and then I'm going to click enter. There we go. So now we have this tag slip period set up here. So now I'm going to keep moving forward. And, you know, there's a little bit of shifting around here, but not too much. And also, you know, one thing we can really look at is what is the whale doing during this period of time? Is the whale, like, you know, breaching a bunch? Is it sort of moving around a lot? Is it diving a lot? Maybe it's feeding, and that could be related. But, you know, here, it seems like the whale is pretty much at the surface. Maybe it's transiting. Maybe it's just sort of logging for a little while. So we're not really seeing much of a shift in these axes. So I don't think there's really going to be any slip in here. And again, one thing to note with all of this, if you do have video, it is really helpful to go and watch through the whole deployment and say, okay, can I see any slips? Is there a time where there's a slip, even if it's sort of between two videos? Because that gives you a rough sense of, you know, there should be a slip here, even if the data doesn't change very much. It does seem like the tag is moving a little bit, and it's something that maybe you just wouldn't pick up if you're doing this process. So you do have kind of these two different ways to validate the video and this data process. So I think there's a little bit of a jump here. Not too much though. Dave, what do you think? Would you classify that as anything? I don't know that I would.
No, and then one of the advantages too is we can come back later once we see the PRH file. So like once we actually start making PRHs, it's robust enough that we can add these in there. So you can always make a mark now and delete it later, and it's not the be all and end all. So it's okay to kind of, we're still kind of arts and crafting it, and eventually we'll start kind of looking at the results of that and be able to adjust it later. We're just kind of looking for first indications here now. And so, yeah, I agree. Like it's probably just probably random noise from whale behavior at this point. And that the most of the tag slips are going to start happening later on in the deployment.
Yeah. So this, you know, of everything here, I would say this is the most clear that this is a tag slip, that there was probably a slip that happened right before this, that it was really starting to shift quite a bit. So I think we're going to put a slip period here. We're going to look and we're going to see if there's really anything. So the whale's sort of at the surface. You know, you can see it's really only at like 1 meter here, but we're within this period of time. So I think I'm going to move back out. I'm going to look at it again. I'm going to say, what if we go right in the middle of this period? Okay, well, this doesn't seem great to me. This seems like a shift, because, you know, we had our Y and our Z axes here, and they were below our X axis, and then all of a sudden up here they're starting to shift, and now they've essentially flipped, right? So something happened here that the tag seemingly sort of turned around. So I'm going to create a period here, and I'm actually going to start it. You know, maybe a little farther back, maybe going to start it here for now. And then I'm going to move it and have it go all the way through here until it sort of starts to even out again. So this is probably the whale fluking pretty heavily. And maybe as it was fluking, that tag was sort of turning slightly. I'm going to maybe put that period to there. I'm going to say this whole period is probably part of that. So if I'm happy, I'm going to click it. And now if we go through, looks like there might have been another shift here where we have this black line kind of jump up a little bit. And it looks like there might have been, you know, a bit of a slow shift. So I'm going to click that there. And again, we do see that the you know, green sort of, you know, something looks like something happened here somewhere in this region. And again, it sort of shifts up. So I'm going to put a segment here. I'm going to start it there. Once again, I'm just going to go through this diving period here. And what's going to happen is for these periods, so the duration of this tag slip, it's going to create this rotation matrix, and then it's going to try to interpolate between. So it'll have the initial orientation and the final orientation, and then it's going to use a quaternion matrix to essentially figure out and interpolate what the orientation should be at each time step in between that. So it's not just moving from one to the next, and then you have a blank space in the middle. So it is trying to figure that out.
And we'll have a request here just to make sure to describe what buttons you're clicking. So if you're left clicking or right clicking or
yes.
pushing a key or whatever.
Yes. Okay. Yes. So when I click, I'll just sort of, let's say there's one here. I'm going to just click in. So I'm going to left click to move in to this screen here. And then if I wanted to set up a boundary, I would click 1 to set the left boundary. I would click 2 to set the right boundary. And then I would click enter once I'm happy to move back to the main screen. Or if I didn't want to put a tag slip here and I decided, okay, that doesn't actually look like one, I would right click to move back out to the main screen.
Can you undo a selection, or do you just kind of X out of it and then rerun section 8?
So let's try it. We're gonna create one right here. So that was, I left click to click in, and then I clicked 1 and then 2 to create that. And so I think if let's say I enter and I like it. If I want to remove one, let's see. So I can sort of enter in there, and then I can right click to remove that tag slip. And actually I think, and Dave, correct me if I'm wrong here, I think I could create one like this, click enter. I think I could right click on it right here.
Nope. I think you have to enter into it to see it.
Okay. So you enter into it and then you right click on it. Okay. Good to know. All right. So we have a little bit of a hodgepodge at the end here. It seemed like the tag was sort of moving around a lot. That can happen if sometimes all 4 suction cups are no longer attached by the end of a deployment. Maybe one of them has sort of popped off, or maybe one of them has been ripped off, or 2 of them, or even 3 of them sometimes. So, the tag might just be sort of moving around quite a bit. And if that's the case, it can get a little hard to sort of calibrate if the tag is constantly in motion. So the end can be a little tough sometimes. But I think what we might try to do is, maybe choose this point here in the middle where it starts to sort of flip. I'm going to click on that. And I'm going to say, oh, wow. Okay, yeah, something happened here. Something that was a little bit tough. So let's see. And it looked like the whale was maybe moving pretty fast here, because you have a lot of up here what we call the jerk signal, or the sort of overall acceleration that we're seeing. And so if you get what we would call a jerk spike, so like a really high peak, that means that either the whale started moving really fast, or it kind of lurched, or something hit the tag. Sometimes the flippers might hit the tag or something. So a lot can happen here. But I'm gonna set one maybe there, and then I'm gonna go through this whole section. So I'm gonna set it. I'm actually gonna maybe go a little bit longer and go to there. I'm gonna enter on that one. I think I'm gonna leave it like that for now. And again, like Dave was saying, we can always add things in later if we need to. But yeah, so right now I have my 4 main tag slips that I think are there. So once I'm ready, I'm going to click enter. We're going to sort of move out of that window. We're going to move back to our main MATLAB. And we're going to see it's going to say section 8.1 complete. And so now that we've done that, I'm going to move along. And I'm going to move on to section 8.2, which is sort of the second piece of this orientation finding process. So now if people are ready, I'm going to run this guy. Okay, so now we have a new screen come up here. And this, again, we're seeing the depth profile, and now we're seeing where all of our tag slips are, so where we just placed them. And what we're seeing in between is, right now everything is red. And so red essentially means it's uncalibrated. We haven't done anything to it yet, right? So what we need to do is essentially move into all of these calibration periods and find segments of the data that we can use to calibrate it, okay? And right now at the beginning, you're gonna see that the pitch and the roll haven't been calculated, so that's gonna be blank. But as we move through here, we're gonna see that those pitch and rolls start to be calculated and calibrated in segments as we move through. So what I'm going to do,
just to give the context too, exactly what Will is saying, just to reiterate what he's saying, is that this is the part where we're transiting from the tag frame,
yes,
where what the tag is representing on the whale, to the animal frame, to being like, okay, here's what the animal is doing in life. And so you can see that even just on the graph right here, that Z accelerometer for the animal, we know for the most part should be at -1, because that's the animal's basic location, is kind of like swimming through the water with a full gravity acting on it. It's not. It's because the tag is off axis. So that's what Will's going to do.
And the y-axis too. The y-axis should be at 0 if the whale is just level, which we can see it's really not. And that's a good point, Dave. To start off, kind of like I said, that the pitch and roll haven't been calculated or calibrated yet. We can see here that that you have your accelerometer in tag orientation frame, so AT for your z-axis, your y-axis, and your x-axis, and then you have your accelerometer in your whale frame, so AW, and we can see that really hasn't been calculated yet. So all we have here is our dotted line. We don't have our solid line yet. So to start this, I'm gonna choose this first calibration period, and I'm gonna zoom in there and try to find some good period of data that I can use to calibrate it. So in order to do that, we can see that there's a little legend here with some controls. So I'm gonna left click to calibrate the chosen section. And when I do that, it'll zoom into that entire section. So we can see that everything just sort of shifted. We're now looking at just that chunk of data. And so what I want to do is look at these surfacings and try to find one that maybe has a nice long sort of flat period here, where it doesn't look like the whale is really changing very much. The orientation is pretty steady.
I'll throw in here too, this is an example deployment of an Antarctic humpback whale that actually comes to the surface and logs at the surface. So we have these really nice flat sections. Most of the time, if you're using whale data or any kind of data, you're probably not going to get this kind of flatness in your graph and in your data. And that's okay. You can select, you're basically looking for the average surfacing kind of orientation of the animal. So you can select a period of time that includes several surfacings. And that's what kind of more typical animal behavior is. And we can show some examples of that this afternoon if we want.
Yeah, and so yeah, like Dave's saying, you might not get something as clean as this. It might be that you need to really work with something here or maybe something there. And we'll actually get into it when we get to this last calibration period, because the tag's moving all around and we don't have a good surfacing. But for right now, since we have it, I'm going to choose this first one here because it looks really good to me. And so the way to zoom in here, if you left click, you'll zoom into a window that essentially has your point that you've clicked in the middle, and then it has 10 minutes to either side, and it'll show you that window. If you'd like to zoom into a smaller window, if you want to get a little more detail, instead of left clicking, you can click the numbers 1 through 9. And what it'll do is it'll create a window with that point that you clicked in the middle, and then the number of minutes on either side that you click the number for. So if you click 3, it'll choose a window that has your point in the middle and then 3 minutes to either side. So it'll be a 6-minute window. if you click 7, it'll be a 14-minute window with your point in the middle. So, you know, if you really wanted to maybe look at this period and you click in and you see, okay, well, you know, it's really, it's showing a lot here. I don't really want it to be showing that much. What you can do is you can click enter and it'll zoom you back out one step, right? So it'll zoom you, if you had clicked in there, it'll zoom you back out to your full calibration period. So instead, let's say I want to go here and let's choose maybe 5. Let's see if that gets us. That gets us pretty well. So again, we can see this is where the tag went on the animal. So you can see there's all this sort of junk noise from the boat as you're bouncing around and trying to put the tag on. And then it sort of smooths out once it's on the whale. So what I'm going to do here is, again, like Dave's saying, we're trying to choose a period of time where the whale is flat at the surface, where we assume the whale is horizontal. And so I think that this period here is really good for that. So what I'm going to do, I'm going to left click the boundaries of that surfacing period. Okay, so I'm going to left click maybe here, and then I'm going to left click maybe there. You see, so that's going to pop up. So that's going to be the period that it uses to calibrate this. And then what I also need is I need one of those pure pitch motions that I mentioned before. So where the whale is going basically up to the surface at the very end when it sort of starts to tip, you know, from incline to flat, or when it starts to dive and it starts to tip from flat to inclined. So, you know, you can kind of look at either side, and, you know, one thing you can sort of look for is there's a little bit of a shift here, right? So you can see that in sort of all 3 axes, there's this little moment of sort of a somewhat consistent slope as everything sort of tilts. But there's also a little bit of noise here because it looked like the whale was maybe fluking a little bit, and that will show up on the accelerometers. So for this one, I'm actually going to look back here. I'm going to look at this ascent period. And what I see is that, you know, this little period right here looks really nice to me, because essentially we just have that really nice slope upward with no fluking, you know, no jagged lines, anything like that. So I'm going to actually choose that period. So in order to do that, I'm going to right click this time. So again, you're left clicking the boundaries of your surfacing, and you're right clicking the boundaries of your dive period or ascent period. So I'm going to right click. I'm going to move. I'm not going to take a huge period of it, but I'm going to right click again. So now we've got that dive portion. And so in real time, once you have both of those, it's going to recalculate your data, and it's going to calibrate it based on what the periods of time that you've given it. So what we can see here is that the x-axis doesn't change too much. It's, you know, it's still pretty consistent, but it's a little bit closer to 0 on average at the surface. The y-axis has changed dramatically, right? And so again, if we're assuming that our whale is flat at the surface, the x-axis and y-axis should both be 0, because neither one is being affected by gravity. And then the z-axis is now closer to -1 than it was before, which again is what we expect. We want that x and y-axis to be 0, and we want that z-axis to be -1. So if all of that looks good and that all lines up, which it seems to be for me, you can also see that it calculates the pitch and the roll at the bottom. Now that it has calibrated, you know, whale frame orientation data, it can actually calibrate that and calculate that pitch and roll of the animal. So once I'm happy with this, I am going to click enter to zoom out. And then, so we can see that it's, you know, looks good the whole way through this calibration period, right? You can see that we're at 1 down here on the z-axis. And if we're good, I'm going to click enter again to accept that calibration for that period. And once that's done, we can see that it's not red anymore. Now it's white. So the goal here is to essentially go through your entire deployment and make sure that there's no red. Make sure that you've calibrated every period. So you don't have to do them in order. That's another piece that's really nice about this functionality. So if I wanted to go to this section now, if I wanted to look at calibration period 3, I can do that. So that's what I'm going to do. And what we're going to have to go through and do here is do all these calibrations. So I'm going to run through all of this so that we can work with the next step. So again, I'm going to left click on this period. And so we zoom in and we see that, you know, this is a shorter period. There isn't really as much to work with here. You know, I'm not looking and saying, oh, you know, this is a better surfacing than that one. And, you know, let's zoom in on here with this exact, you know, number of minutes on each side. Here, I kind of have to work with what I have. So what I can do is I can, you know, I still have to choose a window, right? So even if your window is going to end up being sort of bigger than your calibration period, you can do that. So if I were to, you know, left click, right, for 10 minutes, if I were to left click here, you can see, well, you know, I'm seeing part of this calibration period, but we're also into the next calibration period, right? Which is fine because that just means we're sort of seeing this whole dive. And so what I'm going to do here, and actually one interesting thing to check here too is to sort of check and see if we got our tag slip right, if we put it in the right place. And I think we did, because you can see here, right, that we sort of have this average value, you know, looks pretty good at the surface. And then, you know, it does start to shift a little bit, and we sort of have a different averaging. Now it is diving, so that's part of it too. But it does seem to sort of change a little bit here. But back to this one. So I'm gonna, again, choose my surfacing period by left clicking. So I'm gonna left click here, and then I'm gonna maybe left click. I can, you know, click pretty close. Okay, so we have our surfacing period. Now I'm gonna choose a dive or ascent period. In this case, it's gonna have to be the ascent period because that's all I have to work with. But luckily, this is a really good one. So this period right here, right, where we have this really nice flat portion, I can choose from the beginning of that. And again, I'm right clicking here. So I right click on that, and then I right click here, and boom, I have my dive portion. And again, once that happens, all of a sudden it recalculates and calibrates all of this data to the orientation frame of the animal. And we can check to make sure that it's looking good. We can see that our x-axis is near 0 now, our y-axis is near 0, and our z-axis is much closer to -1. And again, we've now calculated our pitch and roll. And one thing to note too is, you know, it's only doing it for this calibration period. So you can see it cuts off once we move into that next calibration period. And so if I'm happy with this, which I think I am, I'm going to click enter.
Well, a question here: how do you know that you're happy with it? What is it? What are some of the cues? Again, just one more time. What are the cues you see that you're?
I'm happy with it. I'm happy with it because what I'm seeing on these 3 axes, these X, Y, and Z axes, I'm seeing that the x-axis at the surface is averaging around 0. The y-axis is averaging around 0, and the z-axis is averaging around -1, right? Because what I'm thinking is that if the whale is at the surface and he's sitting at the surface, he should be horizontal and level. Obviously, that doesn't always happen with every surfacing, but on average, I think he or she is level at the surface, which means my X and Y axis should be 0 and my Z axis should be -1.
And what's going on with the ascent period there? What are you looking at during the non-surface periods?
Yeah, so for the non-surfacing periods, one thing I can look for is the pitch and the roll. That's another piece of this. So if I'm looking at the roll, I am expecting that when the whale's at the surface, it's not really rolled, but when it's coming up to the surface, well, it's also not rolled. So it's, you know, roll should be averaging around 0 most of the time, unless your whale is super acrobatic and is doing a bunch of things. But in addition, we have the pitch. And so what I'm thinking is that as the whale is at the surface, pitch should be approximately 0, right? Because the whale isn't pitched, it's just sitting at the surface. It's, you know, it's moving up and down a little bit, so there's going to be small variations, but we're not going to have a pitch of, you know, 90 degrees. But when the whale is coming up to the surface during that ascent period, I expect that the pitch is going to be positive. So we're going to have that positive pitch as the whale is swimming upward. Or when the whale is diving, if we were looking at a different period, so over here, right, we can say from the previous, the dive from the previous dive, we can see that as this whale is going deeper, that pitch is negative, right? So I want there to be a negative pitch when the whale is moving down, is diving deeper. And I want there to be a positive pitch when the whale is coming up to the surface. And we're going to see that sort of once we finish these calibrations and we move on to the next, one of the next graphs that sort of pops up, we can use that to really check that and zoom in and say, okay, does everything look good? Are there any places where like things shift wildly and maybe we missed a slip period or something like that? But for right now, that's pretty much what I'm looking for. And I think that looks good to me. You know, this is looking pretty good. You know, even at the bottom here, when the whale is at depth and it's probably feeding and, you know, changing orientation a little bit, you know, we're seeing some changes in the pitch, but on average, it's still averaging around 0 over sort of the course of that whole period. So if I'm happy with this, I'm going to accept it. Now move back. So now you can see I've done these 2 segments. Now they're both white, and the pitch and roll have now been calculated for both of these sections, but nowhere else. So I'm now going to do this big section in the middle. So again, I'm going to left click on this segment. And so now you can see it's a huge segment, so it didn't really zoom in very far. It just zooms into the window of that entire calibration segment. And now, you know, I want to choose one of these surfacings. This one looks really clean. I like the way this one looks. It's just, you know, really clean ascent, a really clean descent. Data looks pretty flat when it's at the surface. So I'm going to choose this surfacing right here. And I'm going to say maybe, let's do 5 minutes again. So I'm going to click 5. It's going to zoom me into a window, which, you know, this window is a little too tight. I want the window to be a little bit more open. So I'm going to click enter, zoom back out to here. And then I'm going to say, let's go in the middle and choose 7 instead. Okay, good. That's pretty good. So it gets us this ascent, it gets us our dive. And so now that we're sort of ready to go, again, I'm going to left click my surfacing period. So I'm going to left click, and then I'm going to left click here. And then again, we have this really nice ascent period, this really smooth shift in the orientation. So I'm going to right click, and then I'm going to right click again. And there we go. So again, we can see that as the whale is coming to the surface, that pitch is positive. And then when the whale is diving, that pitch is negative. We can also see that the x-axis and the y-axis are both 0 now on average, and the z-axis is now really close to -1. So I think this one's good to go. I'm going to zoom to the main screen again, clicking enter, and then I'm going to click enter again. Again, you can sort of check all of these and say, okay, you know, do these look like they're around 0, and does this one look like it's around -1? They do, so I'm gonna click enter again.
Hey, Will, questions popping up here, and I'm going to interpret it as, are you willing to talk about the idea of gimbal lock and roll at depth and roll on the ascent?
Oh, yes. Yeah, I wish I had a little whale here. I don't really have anything. Yeah, we'll use this. No, we won't. That's bad. I'll just use
In the lab, we have a stuffed whale we use. For
there's a bunch of stuffed whales everywhere, so we usually use those. Okay, so we have our tag. So gimbal lock, it's a really good question. Gimbal lock is this phenomenon that we see with the accelerometer, where essentially, if you are looking at an animal that is level, right? We essentially have 3 degrees of freedom here. I'm actually going to sort of move this here. So what can we do with this tag? We can, or with this whale, we can pitch it up and down. We can roll it side to side, and we can yaw it or heading change back and forth, right? So we have these 3 axes of freedom, three degrees of freedom. But that is all based on gravity. So one thing that happens if if your whale tips all the way up, right, and now it's pitched 90 degrees upward. Now, interesting thing has sort of happened here now. If I want to look at a pitch change is still a pitch change, right? But now if I roll this tag, what am I also doing? I'm also changing the heading of the tag. So what we've done here is, instead of having 3 degrees of freedom, I've now locked 2 of those degrees of freedom together, and now I only have 2. So I have gimbal locked this tag and lost 1 of my degrees of freedom. And so that can happen here, and that's actually one reason why we use the magnetometer in addition to the accelerometer to help us, basically parse out a heading change from a roll. Yeah, because this absolutely does happen. If you pitch up high enough, all of a sudden, if the whale turns a little bit, all of a sudden that gets picked up in both the heading column and the roll column of the data.
And that's exactly why you'll see, like in the bottom graph there, when that pitch is really high at close to 90 or really low, close to -90, you get what looks like really crazy roll going on, and it's that effective gimbal lock going on there. And so that's not inaccurate. There's nothing wrong there. It's just that is a product of using pitch, roll, and heading to describe things that they're maybe not actually very good at describing sometimes. And so that is a kind of one of the reference frames we use to talk about animal orientation, but there are other ways as well, including things like quaternions and direction cosine matrices that you can get into. And pitch and roll, during these times, pitch and roll are generally great, but during these times of high ascent and descent that you can see on that bottom graph when that whale is going straight up and straight down, roll is not a great metric there because of exactly what Will just said. But it's good. We're moving forward, but I wanted to explain those pieces. So thank you.
Yeah, for sure. Yeah, and that's something, I think I can zoom back in here. Let's see if I can zoom back into this section. Yeah, you can really see that here, where all of a sudden you have a really high negative pitch and your roll is sort of going crazy. Yeah, if the whale is just, all it needs to do is really kind of like turn like this and everything goes a little bit haywire. Yeah. All right. And that's something too, and while I'm in here, let's go through that a little bit. I can zoom in here to the same spot and if I don't like this, if I look at this and go, I really screwed it up, it just looks terrible. I want to change my dive period. I can, I think I can, let's see, I can press delete to just remove that section, right? And then what I can do, let's say I'm just going to choose something wrong here. Let's right click. Okay, well, it didn't like that. It very much didn't like that. But one nice thing about this is you can run this section. I can say yes, and it'll open it back up for me, and we're good to go. It doesn't, it saves your calibration periods and the calibration data that you've chosen, so that if you need, if you have a deployment, and with some of these tags, sometimes it'll happen where you have 50 different deployment or 50 different calibration periods, excuse me. The tag was just slipping the whole time, or it was on for, 5 days or however long, and there's a huge amount of calibration periods, and you only have an hour to do it, right? And you're going to have to come back later. You can do a few of these and then close out of this and come back later and do the rest. So you can work through what's easy, or you can work through some hard ones, or basically do it in whatever order you need to do it in. And just to do it, I'm going to jump in here again, and we see that, okay, it kept what I had before, because the new thing I put in, it just really didn't like that, which is good. Okay, so I'm going to do these last few segments here. So I'm going to left click, zoom in here. Okay, once again, we're in these sort of smaller periods that don't have as much data. So I'm going to click over here, and I'm going to say, let's do 5. Okay, so that's not too bad. And again, we're sort of already into the next calibration period, but we can see this next calibration period is going to be interesting, because there's a lot of sort of noise in here. But for this calibration period, I'm going to left click. Left click here. And then I'm going to choose, again, we have a really, really nice ascent period here. So I'm going to right click. I'm going to right click. And there we go. So let's see. We are averaging around 0. We're at the surface. There's a little bit more noise this time, but still not bad. Again, we're averaging around 0. And then we're averaging around -1. And let's check our pitch. We see that we have a positive pitch when the whale is coming up to the surface, which is good. And we can actually kind of see that, sort of taper off slowly as the whale comes to the surface. And then it's 0 when we're at the surface. So we're good here. So I'm gonna zoom out. I'm gonna check it just to see. Again, we have negative pitch on the dive, positive pitch on the ascent. Looks like there might have been some heating going on here, because we have some quick changes in the pitch here. But otherwise, everything looks pretty good to me. Zoom back out. Okay. So now it's just this last period, which is going to be fun. And this is where the arts and crafts really kind of comes in. So I'm going to left click, zoom in. Oof. Okay. Well, this is something. And so we can see, approximately where the tag came off, somewhere over here. You can see it's kind of looks like it's just shifting up to the surface now. There's not really anything going on. But this is really sort of all at the surface. The whale, it's only 15 meters. It's not much, not a huge amount to work with, but we're gonna do the best we can. So for this, surfacing, I actually sort of like this little period here. I'm saying that because it looks a little more stable to me than this does, just with these, you kind of have a spike here, you have a little bit more of a spike here. this period just looks a little more stable. So I think I'm going to choose this. So, you know, in order to do this, let's say our surfacing period, it includes a lot of this fluking signature, but let's say maybe from here. So I'm going to left click. Oh, whoops, sorry. Sorry, I have to zoom in again. So let's say 3 minutes on either side. So it doesn't change it very much. Okay. Okay, so sorry, we're back to here. So I'm going to left click maybe here, and then let's give it a little more room, maybe to about there. Go a little bit farther. And then I'm going to choose this ascent period. You know, it's the whale's sort of fluking this whole time, but it looks like there's, you know, maybe a little bit of a portion right from about there to there where the whale is coming up and it's a little more steady. You know, you can kind of see there's a little bit of a steadiness here. There's a little bit in this y-axis, not as much in the x-axis, but that would sort of be the axis that would pick up most of the fluking motion, if that's the case. So let's go with it. Let's see how it does. So I'm going to right click. I'm going to move here. I'm going to right click again. All right. So let's see what that did. Honestly, not too bad. So we can see that we're, you know, again, you have a lot of this fluking signature, but it's pretty close to 0 for the x-axis. It's pretty close to 0 for the y-axis, and we're pretty close to -1 for the z-axis. So to my mind, that's not bad. Again, we sort of have this pitch around 0. And we can see it gets a little bit wonky over here as it's popping off the whale. And there's a little bit of craziness here. You know, the whale might have breached or something, or just gotten hit or turned. But honestly, that looks pretty good to me for sort of what we have to work with on this calibration section. And so if I'm happy with that, which I think I'm as happy as I'm going to be with this, I'm going to click enter to zoom out. And I'm just going to sort of look and see, okay, you know, does that hold for the entire calibration period? Yeah, we're pretty close to 0, and pretty close to -1. It's actually, that looks pretty good to me. And then we're going to press enter again.
Well, before you exit out of here, there was a question to demo the tag slip mode as well.
Tag slip mode. Yes. Okay. So let's see. Okay. So let's say that there was a tag slip in here somewhere. We really want to sort of change it around. So I'm going to hit the T button, which will enter adjust tag slip mode. Aha. So what this allows us to do now is we can actually see the pitch roll and the heading on the bottom there. So it allows us to left click and create a new tag slip period. And what it'll actually do is it'll recalibrate that chunk. So if I were to click here and create a new tag slip, it would essentially split this calibration period into 2. And one of those has already been calibrated based on what I had done before, but one of them now hasn't. And you'll see what that means in a moment here. But you could also you can adjust the nearest tag slip to sort of start in a different place. Or you can press delete to delete the nearest tag slip if you put one in there and you decided I really didn't like it. So let's start and let's say, okay, we have a tag slip here. So I'm going to left click. Boom. Okay. So I just added in a tag slip and you can see what it did. So this period, I mean, initially this entire period was calibrated based on the data that I chose on this surfacing here, right? But now I've split that into two. So since I had clicked here, this section is still calibrated, but this section now needs to be calibrated anew. So yeah, so I could essentially enter and go back to the prior mode, which I can do right here. And all of a sudden now, once again, I can enter in and I can, choose a new calibration period here. Okay, so let's just do this. Just for the sake of doing it. Let's do left clicking there, right clicking here. Okay, we're all set. This looks good. This looks good. This looks good. -1. We have a positive pitch. We have a negative pitch. Looks good to me. Still looks good. Now we're going to zoom back out. So, all right. So we just added a tag slip in here. But what happens if we don't really want that tag slip to stay? So what I can do is I can go back into my tag slip mode. And let's say that I, really don't like the place where I put my tag slip, right? I want to just move it somewhere. So if I click 1, it'll take a little time to sort of recalibrate, but it'll change that start time. And then if I click it again,
The long tag slip.
that's the long tag slip. So what I did here, if you click 1, it'll adjust the start time of the closest tag slip. So for this one, it adjusted the start time of that one. If I was clicking in here, it would adjust the start time of the closest one, which was this tag slip near this number 4. So if I were to click in here, it would pull the start of tag number 5 or slip number 5. So actually, I don't really want that to be that long. So I click and I can make that smaller again. And here, once again, I can kind of make this smaller. So again, I'm just clicking 1 to sort of, make these a little bit smaller than they were before. And then what I can do is I can, if I really just don't want this tag slip to be here, I can hit delete. And it has to sort of reprocess, recalculate, and it'll remove that tag slip. Right? So if I really don't want one to be there.
And well, if I can, there's a couple of questions just to give a kind of just one more variation on like how we're looking for tag slips and stuff. So as you're zooming in for these things, and that's why sometimes the heading can help. What you're looking for is periods where that are still maybe you're looking for a jump in the data. So if something doesn't really look smooth, oh, okay, well, it looks good in this section, but over here the pitch all of a sudden is not quite at 0, and you see that better in some of the zoomed in modes. But if you're and you can do the tag slip mode from the zoomed in modes as well. But you'll look for a spot where where even here towards the end, there's probably a couple other tag slips you could add in there. But the idea is that you're looking for a spot where all of a sudden the data is askew. And if you could add in a different calibration period for that small section, it's good. Often you can't always do that because because maybe the tag slip it slipped twice while the whale's at depth, and you don't have any way to calibrate that because you don't have that surface period of calibration section. So that's just another time where you have to kind of know your data and know okay, well, actually for this dive, the data might not be very good because we can't really calibrate it because the tags slip at the beginning of the dive and at the end of the dive. And I can't calibrate during that time because there's no surfacing to account for a known orientation. So there are periods like that. A follow-up question was between, if the tag slip is some amount of time long, how does it interpolate between those? And the answer is it basically takes the calibration before the tag slip and after the tag slip and interpolates throughout the duration of that tag slip to say like, okay, it slow rotation between one to the other. And that new aspect, yeah, it's like a steady slip rate, essentially. It's like it assumes that a slow slip between those periods, which, might not be the perfect assumption, but it's kind of the best assumption we can. Now, because of that new functionality, we actually have our first toolbox errors cropping up from people. If you don't have the Aero, A-E-R-O toolbox in your aerospace toolbox in your MATLAB version, you might be getting this error that the DCM to quat, which is a quaternion direction cosine matrix to quaternion function, does not exist in your path. And so I am doing my best to cheat the system right now and add that into our toolkit. So I am grabbing that and I will put that up on the GitHub so that when you update it next time, you should be able to have that. And if you run that again and you got a different error of a different function, this is part of the game of like who's got what, we will add that in and hopefully you can tell me what other functions are giving you errors for this. So I have that now added into the GitHub.
And so I'm getting an error here that does pop up sometimes. If you run this, it'll ask you if you want to start with the previously saved W and cal period, which I do want to do. Sometimes if you've created your tag slips, it can get or if you add new tag slips or you've kind of done a lot in there, sometimes it can get a little bit confused. Do you want to use the new tag slip? So even if I say no, it'll tell me to check my input parameters. That does happen sometimes, but theoretically, I'm actually gonna stop sharing now. If I were to run through, no. Okay, let's do these again. Okay. So how about while I'm running through this really quickly, if everyone wants to just take a few minutes to, just maybe 2 minutes to look at this and see if they have any other questions on it.
Sorry, to look at what, Well?
Oh, just to sort of go through this if they're following along and see if they have any other questions.
Yeah. Essentially, we're moving close to our 1 o'clock period. We kind of pushed right through. We had promised a break and we didn't take one. So hopefully everyone's doing okay for your for break needs. But we're getting close to the end of our period today. So we're actually going to run one more script, which is another one that can take some time. So it's a good one to kind of end on and set us up to finish the speed and PRH files tomorrow, which will be to make a flow noise file. So we'll only do one more today. And that relies on having your audio data file structure set up. And so we'll run that and we'll kind of leave it at that today. And we'll start by doing speed tomorrow. And to get us ready for that, just to kind of watch along as you're finishing up your code, I'll just share one thing here, just to kind of think about where we're going with this. Let me share one thing here. One more question about tag slips before we get into it. Is that there is I see some other errors too. Okay, one more question is, yeah, when you're adding tag slips, you can also adjust by like what Will showed you there. When you add in a tag slip, it starts by assuming a single point, but then you can adjust that start of that tag slip by pressing 1 in that tag slip orientation period.
One very quick thing, just before we move on, once you've locked in all your calibrations, it will come up with a few different figures that basically show you your data and what it looks like. And this is another place where you can kind of check it and say, okay, this looks good. This doesn't look great. Let me go back and sort of redo that calibration period. So you can see here, you have your tag for your accelerometer, you have your tag frame, and your calibrated whale orientation frame, your animal frame. And then we have that versus the depth. And then we have the same, so we have the pitch and the roll. These are both, again, calibrated into the whale orientation frame. We have the gyro data, which, you know, again, we just shouldn't really be seeing any huge spikes while it's on the whale. And then finally, we have the heading. So you can kind of check and see, like, are there any like crazy spikes in the heading where the heading is jumping, you know, 180 degrees in one, you know, one data moment. You know, if that's the case, maybe there was a slip there that you just didn't find. So yeah, that's sort of the output from this section. Again, is just kind of another way to check.
Right on. That's awesome, Will. Thanks. I know there are probably still questions about that and using that for your data, but that's kind of the foundation of all of this stuff. That's kind of the main goal. Once you have your tag kind of calibrated on the animal, the rest is gravy. The rest is like, okay, now we can do things with it. Like once you have that, then we're kind of like, we've got calibrated data. We've got the tag oriented to the animal frame. We can really trust our data now. Everything else is like calculations and interpretations of the data. And we'll talk about how to like do things like calculate speed. We'll pick up there tomorrow and we'll make pseudo tracks and stuff tomorrow. But that's kind of the main piece. Like once you've done that, once you've been able to do that with your data, you're like doing cool things. You're making progress. So we'll start one more thing for you to try to run tonight, which is related to the speed. We calculate speed in a couple of different ways, just to kind of set us up for that. Speed is notoriously hard to calculate on tags. Some versions of tags, like Little Leonardo's, do often have a speed sensor on them, but they're just like everything, it's hard to calibrate that correctly, because if the tag is in a different orientation than what you tested it in your flow tank, it's going to take flow in a different way. So a lot of these things, and it's hard to get a propeller to work at the right speed. If anyone, like, it's kind of the next big biologging thing, if you can come up with a really good speed sensor, that would be awesome, particularly to help get low speeds. So the way we've been doing speed is to use essentially noise in the ocean, either from, it's like equivalent to like measuring how fast something is going, how fast your car is going, by how fast your dog's ears flap out the window when your car is going at 60 miles an hour down the freeway. So it's equivalent to like measuring it that way, but that's kind of the best method that we have right now. And so we'll show you how we do that. And there are some limitations to that, and we'll show you how and why, including like, it's hard to measure slow differences. You need a certain amount of noise in the system in order to be able to measure speed at all. But when I talk about noise is this idea. So noise can come in a couple of things. One is we saw in some of the tag deployments, and actually show that one first maybe. This loads up. In a couple of tag deployments you've seen, like there's noise underneath the water, right? So, actually this one doesn't have flow noise, I forgot. But one of the things you'll see here, so you can imagine as this whale starts to move and go faster and faster and faster, you can imagine it getting louder. That's essentially the flow noise, the flow over the hydrophone. And so if you have audio data in your CATS tag or in any data or in D tags, you can measure that overall amplitude of the flow noise to get a sense of the louder it is, the faster that animal's going. So that's one of the things we'll do and calibrate in the next step. This is an animal breaching here in Monterey. The other thing you saw there is, and I'll back it up a little bit, is you saw that you saw this tag, the camera kind of start to shake a little bit as that animal is going really fast, right? You can see that kind of like that, we call that the tag jiggle. You can see that animal, that tag really kind of start to move there. And in a flow tank that looks like this, where you see that basically that tag is just vibrating as the flow is going over the tag at 3 meters per second. Here's a really slow, high resolution. You can see that tag just kind of move back and forth. That's noise. That's accelerometer noise in the system. And one of the reasons we calculate data at a high frame rate, where you calculate accelerometer at a high sample rate, is to capture that noise. And that noise we can actually then turn into a measure of speed. So between those two metrics, we have two different ways we calculate speed with these flow noise and with these ideas. So we'll basically set it up to start the first cell of that today, which is calculating flow noise. So it's basically, we're going to skip step 9. When we say that we're like, still everything's in progress, step 9 is like a way to calibrate and unbias a gyroscope. That's a strict that I wrote 6 years ago, and I do not recommend it. So I have it in there so you can maybe use that as a starting place. If you ever want to get into like calibrating gyroscopes better, get in there, because it shows some of the same ideas with quaternions or whatever, but I have it uncommented or commented out so that you don't run that cell. But it's provided it, although it's against my needs. I'm showing you my vulnerabilities there, gyroscope vulnerabilities. So if you ever want to get into it, get into it. But the one we want to run is the one after you finished your calibrations that Will just did. Now we want to bring in those movie files. So we want to bring in this is where now that all that work you guys did earlier to create closed it, to your audio data folder with all of your audio data in there. That is now going to be brought in, and we're going to read the flow noise off the tag. So even if you don't care about acoustics at all, there's still some usefulness here to be able to read flow noise and to be able to calibrate speed. So the last thing we're going to have you run, and this will kind of take some time to run. So we're going to have you guys run this essentially for the next little bit while we take a break, and then we'll come back tomorrow morning and we'll wrap up some of this tags, speed stuff, and the PRH files, and then get into some of the video processing things before we get into a couple of the other examples from people about how to use this data. And so we have some wiggle room on Friday as well. If we don't quite finish everything up through the PRH process, we will definitely finish by Friday morning. So we have some wiggle room in there, so we can make sure we give good presentations from people tomorrow, as well as talk about how to use these data. So we'll get through finish the speed tomorrow. So this one, basically there's not much to think about here. It's just going to load that info file again with all that information. It's going to load from your file structure. You need to have that audio data folder in your structure here with your different pieces, and work from there. So I'm just going to click Control Enter here, and it's going to start overriding those. I just already wrote that once, so it can do those things. Oops. Want to rewrite it. So it's going to start running through there, and it's going to basically import all those audio files and read those videos in one by one. So it's saying, okay, the sample rate of my video is 24 kilohertz, and it's going to kind of read in one file at a time and going to get through and eventually end up with a flow noise variable that will look, spit out a plot. It's going to look something like this, but completed throughout the whole data set, where it's going to show you the flow noise, which is a metric of speed, and it'll be faster when that animal's moving faster, when it's doing these lunge feeding events, or when it's descending or ascending, and lower when the animal is doing things like rest at the surface. And then the next step tomorrow morning, we'll talk about how to actually calibrate those. So that's all we really have today. Let's check, I'll check the chat one more time here for questions.
We had one good question that's a little bit outside the box in terms of the whales. If you're tagging a fish or another animal that doesn't surface the same way as a whale, can you use periods of time where you sort of have a good sense that the animal might be horizontal to calibrate based on that?
One advantage to working with fish is that usually you put the tag on yourself. And so you know the orientation as you're putting it on there, and you can calibrate it when it's like on your table or whatever. So, like a lot of what we're doing is putting on a tag in a random orientation because we're tagging a wild animal in the wild. But if you actually have control over how your tag goes on, then you can do this adjustment either mathematically or like at a time when you know the animal's orientation, because it's like on your bench and on the deck or something.
And then one more, when you're adding in tag slips and you're adding them in that cell 8.2 while you're doing the calibrations, is it okay that you're adding them in as a point at that point, versus having full control over the start and end time?
Yeah, I think we mentioned that is just I think maybe earlier on is just the idea that when you enter in the point, yeah, you press 1 and then that can adjust the tag sub, the beginning of that tag sub location. So you can add that functionality.
And then we had one just now. We're getting an error: output argument odd, and maybe others not assigned during call to get flow noise.
I think that we found that error yesterday, and so I think if you update your CATS tools, it should be better. Hopefully that should fix that error.
Yeah.
And if not, then we can troubleshoot that this afternoon. Your output file should end up looking something like this, where you have your flow noise input into your file, where you can see exactly what I was talking about here, where at the times where the whale is diving, where during this depth, you can see that flow noise, that noise in the hydrophone get really high. And we don't know what the units are yet. It's just here in decibels of flow noise. And we don't know how these relate to each other yet. We'll calibrate that tomorrow. But you can start to see that increase in flow noise as that whale is descending, because it's going faster and faster and faster as it descends. And you can see it on the ascent. You can see these fluke strokes that Will was looking at in the pitch signal. You can see that also happening in the flow noise here. And then you can see these lunge feeding events for a humpback whale in here, where you can see these individual increases in speed followed by a rapid decrease in speed, which signifies for us a lunge feeding event that Sherelle is actually going to talk about some of that event detection stuff tomorrow. So great. I think that's all we got for today. Thank you guys for your work there. Hopefully the example was able to work through for everyone. And if not, if you want to work through some of your own data or some of your own questions or problems that you had on your version working through it, then we can, some of these things will just be fixed, and the next time you run it, it'll work better. And so it's hard to do them in real time, but it's always good to make sure it works on your version. So nice work.
Looks like there's at least one other person who got that same error, and they said they updated their code 3 hours ago. So yeah, we'll do a little error checking on that.
Okay. Yeah.
Yeah.
It could be a version. What version are people using in MATLAB for that, so that we can figure that out? Let's see if that's the issue. We'll roll that out. I think what it actually might be is a problem that the problem might be coming if the audio that file, if you're not reading audio files, that might be giving you that error. So your audio data folder that you created on day one, overnight on day one, with all of your movie and wave files and audio structures, need to be in a folder near your truncate and all these other files. So you need to have that folder for it to look for those structures. So if it's not seeing that structure, that might be creating that problem.
I can share my my screen here just to show sort of how that's.
Oh, and you know what?
So I have my folder here, right? And so within there I have all of my raw data and everything. But this is basically the file that I've been working off and working out of for all of this. So I have my my initial mat file, I have my info file, my movie times, truncate, everything in here. And then I also have my audio data folder. And in there I have all of my wave files. So that's kind of how I have that set up.
I know what it is. It is a 2020 version. I was having this when I tried to run everything in 2020. It's basically, there's the new 2020 version has catches in there, so you don't mess up and do poor coding. So like we do a lot of loading files, like we load that audio file structure into the environment. And then MATLAB essentially is looking for that odd structure. It's looking for that AUD file, which is an audio structure with all the data. And so it's looking for that in 2020. It won't let you move on. It's giving you that error because it doesn't see you load that file specifically, even though I had it load the whole file. It doesn't see you load that variable. So great. So I've fixed that in a bunch of other places, but I'll fix that here too for 2020. So you guys are right. It is not updated, but it should be. I should have just fixed it right now. And so let me just error check that real quick before I throw that onto the web, but that should be better now. All right, that should be better. All right, I'll check that in 2020 next, but I'll pass this on to you guys. It should be good. Cool. It is really helpful. I know I know it can be annoying, but it is really helpful to have all you guys kind of error checking as we go to get all these different versions going on. So thank you so much. Sorry, I interrupted someone with a question.
I was just gonna say so it's running through step 10A right now, and it's gotten to a point where it's at files where it's saying warning audio 19 does not seem to be on the whale skipping.
That's okay.
Should we have taken those out? I mean, I guess we don't really know where that point is, right?
It is warning you because it's saying that, okay, that's not in your data file, but that's okay. Like if it's not in your data, like it's going to give you the warning, and it just meant that you left your data files in there that are off the whale, and it's just telling you that. So it's just mean it's not useful information, but it's fine. That we put that try in there specifically for that purpose, to say like, so that you don't have to mess with your file structure too much. So it should be fine. Yeah, we just know from earlier that audio file 18 is the last one on whale. Cool. Great stuff today, guys. We'll sign off for now so we can start making the recording for people. But we'll sign back in at 2 o'clock and see how everything's going. Thanks, everyone, for this. And we'll see everyone tomorrow morning. So good to see everyone's faces.